of donning or putting on those ox suits. As this is the first flight of humans on the spacecraft, we're using this entire mission as a test for all systems. That includes using these suits for survival if needed. If the spacecraft were to depressurize, the crew would be able to put on their suits and have a breathable environment for up to 6 days. This is the first test of the crew putting on these suits in the microgravity environment. They will then pressurize them and get into their seats, conducting some tests along the way.
Hey Jenny, can you check the WAP and make sure the WAP is still connected? We just had, we crimped the Ethernet cable when we removed the seat 3 seat pan.
Checking. And Reid, we see a nominal connection to the WAP. Everything looks good. Thanks for letting us know anyway.
Acronym breakdown for you. WAP stands for Wireless Access Point. The crew is continuing to set up for the Aux suit demo. That's Orion Crew Survival System.
Houston Integrity for seat restraints.
Go.
Hey, Jenny. We have elected, if you agree, to not use the crotch belt seat restraint tethers because we see that they are floating and we think that they will be easy to retrieve without the tethers.
Copy. That looks really good to us as well. Thanks.
Inside the Orion spacecraft right now, the crew continues to step through their procedures during the Ox suit demo. This is Orion Crew Survival System. NASA astronaut Christina Koch is taking pictures of the configuration of the seats so far. Again, on this test flight, everything is being carefully documented so that it can be used in reference and for planning for future missions aboard Orion. Again, the crew will be putting on their Ox suits during this demonstration. Nominally, or on average, they would only wear these during launch and re-entry. But for this mission, we are testing out what they would need to do if there were a depressurization in the cabin. These suits would provide them a breathable environment for up to 6 days, and they also have the ability to take medicine, eat, and drink while in the suits, so all of those things will be tested out today. Now, once they put on these suits and pressurize them, they will expand a little bit, and it'll make it a little more difficult to move about the spacecraft. That's why this test is so critical to help team members write future procedures for future crews.
Hey everyone, quick note on how the harness straps are sent up. If you can see, when they were sent up, both of these were all the way flush with this, and it made it pretty hard to start the pull out to make them be adjustable. It would be great if they're just separated and maybe flown in a config like that.
Copy and noted. Thank you.
If you're just joining us, this is Artemis Mission Control, now on flight day 5 of the Artemis II mission. The crew and spacecraft are now over 219,900 miles away from our home planet of Earth, 57,850 miles away from the Moon. The crew woke up today at 11:05 a.m. Central Time, and after their post-sleep period, quickly got to work. This is the Ox suit demo, Orion Crew Survival Systems suit, those orange iconic suits that you saw them wear during launch and that you'll see them put on ahead of splashdown. This demonstration is to test how the crew would get suited and seated if needed in the event of a cabin depressurization. This demonstration is expected to take up most of the crew's day ahead of the midday meal, with that midday meal coming around 6:30 p.m. Central Time. In the remaining half of the day, the crew members will obviously have their midday meal. They will also get into some burn monitoring operations. We are expecting the outbound trajectory correction 3 burn today at 10:03 p.m. Central Time. Outbound trajectory correction burns are small maneuvers using the reaction control system thrusters on the spacecraft. These help refine our trajectory as we are heading around the Moon and coming back to Earth. The initial burn to send us on that flight path was executed on flight day 2. That's the translunar injection burn. We previously canceled OTC burns 1 and 2. The trajectory was sufficient at that time, and those were not necessary, but the team does intend to execute OTC 3 this evening.
We see that in the video. Thanks, Christina.
Okay, just to update you, Jenny, we finished all the seat config stuff. We're grabbing out the snacks now and continuing.
Copy, that sounds good, Christina. And just to let you know, we have a pretty big delay on the video, so for things you're trying to show us, we just might call them a bit late.
Houston Integrity for timeline sync.
Go ahead.
Jams, we are nearing the time of having y'all go off board so that we can get into our suits. Just wanted to check in with you on timing or anything else you've noted that you want to share before we get into that.
Thanks for letting us know, Christina. That syncs with everything that we've been tracking. We just want to update you that we don't believe that we will do any objectives at the lower pressure, so at 3.7 PSID at your suit delta pressure, and we're also looking at adjusting the objectives during the first set as well. So we'll continue to talk about that, and in the meantime, you're go to continue.
This is Artemis Mission Control on Flight Day 5 of the Artemis II mission of our 4 astronauts around the moon. A major activity for today is the Ox suit demo. That is Orion Crew Survival System suit. The crew wears these suits, that orange iconic color, during launch and re-entry. They would also wear them if needed during a depressurization in the spacecraft. Obviously, we are not tracking that today, but this is a great practice opportunity for this crew to learn how to put on these suits and get into their seats. Everything that we learn on this mission, it helps us.
Integrity Houston, we still have a camera view. We see nothing, but it looks like part of the side of the DU, but wanted to let you know it's still on.
Everything we learn on this mission, including the steps taken today, help us prepare for future crewed missions aboard the Orion spacecraft. Now, while we expect to have more views coming back from the spacecraft, the crew has asked that we go off board for a moment while they don their liquid cooling garment and their comfort garments that they will wear under those suits.
Integrity, that is a better view on the camera. We are a little worried about it becoming unstowed, but right now all we see is the plastic bag and part of the Pelotor. So that's good for now, and a reminder, we'd love timing for your suit up.
On your screen in the black is Capcom Jenny Gibbons, Canadian Space Agency astronaut and backup Artemis II crew member. To her right, Capcom Tess Caswell. This view a visualization of the Orion spacecraft, its current orientation and distance to the moon, which is now 57,323 miles, continuing to grow closer by the minute as the spacecraft is traveling 1,554 miles per hour. You can access this at any time by visiting nasa.gov/trackartemis. A recap of who we have flying aboard the Orion spacecraft for the Artemis II mission. We have Commander and NASA astronaut Reid Wiseman, Pilot NASA astronaut Victor Glover, Mission Specialist 1 NASA astronaut Christina Koch, and Mission Specialist 2 and Canadian Space Agency astronaut Jeremy Hansen. Currently, the crew members are getting into their OX suits, those Orion Crew Survival System suits. This is part of the demo during which those suits will be pressurized and also have leak checks. And if you're just joining us, this is all a test. This helps us determine how the crew would need to ingress or enter those suits quickly in case of a depressurization in the spacecraft. They'll also need to enter or put on their suits ahead of returning to Earth, as these are what they wear for launch and re-entry.
Houston Integrity, we are bringing you back on board. Let us know if you don't see it. We haven't dawned, but we think that we're okay with you all watching the full dawn from comfort garments.
Copy, Christina. That sounds great to us. Thank you. We did see you adjust the camera, but we no longer see video.
That's being worked.
Thank you.
And with that, if you agree, we will allow you all to determine suit donning, start, and complete time for the rapid and nominal.
Copy.
As you heard from NASA astronaut Christina Koch, the crew are now in their comfort garments, and they will continue putting on or donning their OX suits, Orion Crew Survival System suits.
All right, crew, we have video.
As you can see inside the Orion spacecraft, it is significantly more crowded than we've seen over the last few flight days. The crew has reinstalled some of their seats, and they will begin getting into their Orion Crew Survival System suits. 2 of them will practice this at a rapid pace, and 2 will practice at a normal pace. Again, this is all in preparation for future Artemis missions. It's all preventative in case the crews would need to don or put on these suits while in a depressurized environment. It's going to get even more crowded in this image. Once the crew puts on their suits, they will be pressurized. So they grow in volume, and the crew will need to maneuver around the cabin while still connected to umbilicals as well to get into their seats. Currently in the Orion spacecraft, you can see crew members starting to put on their OX suits. That's Orion Crew Survival System. Those are the iconic international orange suits that the crew wears during launch and re-entry, and they would put on in the event of a cabin depressurization. So today is a test to understand how the crew needs to put on these suits in a cabin depressurization situation. This test helps us refine procedures for future crews that fly on Artemis missions. These suits are developed by the OX team, again, Orion Crew Survival System. They are monitoring today from the Mission Evaluation Room, also known as the MIR, at the chess console. That's Crew Habitation Equipment Support Systems. This console provides expertise on the crew systems and equipment that the astronauts are using throughout the flight. Once the crew are in their suits today, they will need to conduct suit leak checks as well as enter or ingress their seats. They'll have some additional tasks like drinking and eating while in the suit, as well as taking placebo pills through the pill tool. When these suits are pressurized, we do expect it to become more difficult. Again, once we get the crew into these suits and they are pressurized, they will also be on umbilicals. So these are adding a little more difficulty to moving inside the spacecraft and getting seated.
Integrity Houston, we're following along on video. A reminder, when you are moving about the cabin, we want the strain relief carabiner attached, so your umbilical to your suit, and we would also like Cobra buckles fastened for, at minimum, the 2 free float leak check crew members. Copy, thumbs up.
Houston, integrity com check, seat 1.
Reid, we have you loud and clear from seat 1. How me?
Loud and clear. Houston Integrity comm check from seat 2.
Seat 2, we have you loud and clear. Help me.
I have you the same. Houston Integrity, seats 1 and 2, rapid on complete.
Copy. Rapid dawn complete. Seats 1 and 2. Thank you.
That call coming from Commander Reid Wiseman, NASA astronaut aboard the Artemis II mission, down to Capcom or capsule communicator Jenny Gibbons. The crew is conducting their OX suit demo. That is the Orion Crew Survival Systems suit. And as you previously heard, a voice check from NASA astronaut Victor Glover, the pilot on the mission. He is in his seat. Wiseman confirmed the same and that the rapid suit.
Integrity crew, low priority camera adjustment. We will take a tilt towards seat 3. That is more toward the Equus wall and the lockers if able.
Again, as part of this demonstration, 2 crew members were getting into their suits rapidly, and 2 were getting in at a regular pace. These are the suits the crew wears during a launch and re-entry, and they also could provide up to 6 days of a pressurized breathing environment if the crew needed them during a depressurization of the Orion spacecraft. We are taking advantage of this mission as a test flight to help us prepare for all future flights of astronauts aboard Orion. Mission elapsed time of Artemis II, now 3 days, 22 hours, and 7 minutes. In addition to today's suit donning demo, The crew also is scheduled to see the outbound trajectory 3 burn. That's going to be at 10:03 p.m. Central Time. Those outbound trajectory burns are refinements of their trajectory around the moon. We did cancel the OTC 1 and 2 burns. They were deemed not necessary by the teams here on the ground following the translunar injection burn that committed us to flying around the moon and then splashing down in the Pacific Ocean. We are planning to proceed with today's OTC 3 burn, again, just to refine our trajectory ahead of lunar flyby tomorrow.
And Houston, we'd like to just get a big picture sync across the crew right now.
Absolutely, go ahead.
Let's just sync up so we know where we are. Ike and I are in seats 1 and 2. We are fully suited. We do not have umbilicals connected. And we are in suit on vehicle config step 5, and we are holding there. And then Christina and Jeremy are suiting up on a nominal suit up right now. We believe that's where they should be. Christina has not begun suiting yet, so I think we need to know from you if you could take the operational lead and start walking us through where these 2 distinct groups should be, Victor and I, and Christina and Jeremy.
Copy, Integrity crew. You are all where we expected you to be. Jeremy and Christina can continue pressing with the nominal suit on, and we will have you and Victor pick up with commanding umbilicals to perform the first leak check with 2 crew members. And remember, I have a delta for you on the visors open vent path.
We will always vent overboard today. Stand by.
Good words.
All right, Jenny, and just confirm that you want Ike and I to run 22.2.101 suit on vehicle config for the first 2 crew member leak check. We are not running this from the DFTO, and we will vent overboard.
Affirm.
Okay, thank you.
Now that Victor Glover and Reid Wiseman are suited and in their seats, they are going to step through the leak check procedures. Again, if you're just tuning in, this is a demonstration of the crew putting on their suits on the Orion spacecraft. They would need to do this on orbit if there were a depressurization of the cabin. Otherwise, they wear them during launch and entry. Everything we learned today helps us prepare for future crews to fly on Artemis. And we expect the team to be calling down questions and reports of their status as they move throughout the procedure. With Reid Wiseman and Victor Glover suited and in their seats with leak checks beginning, Christina Koch and Jeremy Hansen, mission specialists for the mission, are continuing to put on their suits. Two crew members, obviously the commander and the pilot, were asked to put on their suits in a rapid fashion, while our mission specialists were instructed to put on their suits with a normal timeline. Today we are going to be pressurizing the suits to 4.3 psi, on top of the cabin being at 10.2 psi. When these suits are pressurized, they do gain a little bit of volume. You're looking at a live view of Artemis Mission Control here at Johnson Space Center in Houston, Texas. This is the Orbit 1 team on console.
Houston, seats 1 and 2, leak check complete.
We see the same.
That voice, our capsule communicator for today, Jenny Gibbons, Canadian Space Agency astronaut, and Artemis II crew backup. To her right is Tess Caswell, fellow Capcom.
Houston, just confirm for me and Victor, the next step is to go back to step 5 and suit on vehicle config and hold for seats 3 and 4.
Affirm, Reid. Once Jeremy and Christina are suited, we will have them join you for the next leak check. Your procedure path is correct.
We copy, thanks.
Flight Director Jeff Radigan in red on your screen, leading the Orbit 1 team. Just heard communications from Commander Reid Wiseman aboard the Orion spacecraft, calling down that suit leak checks are complete for he and NASA astronaut Victor Glover, pilot of Artemis II. Meanwhile, aboard the Orion spacecraft, mission specialists Jeremy Hansen and Christina Koch continue to get suited ahead of getting in their seats for their own leak checks as part of this demonstration.
Jenny, do you need something different on HHP? I think I can reach it from here and try to re-aim it.
Affirm, if you can reach it, we will take a tilt downward toward the lockers, please. Reid, we like that view. Thank you. Integrity crew, I see Jeremy and Christina nearing the end of their suit dawn. I just want to remind you about the gas trap, which needs to be capped. 5 minutes after the last crew member connects to cooling, please let us know when that's complete.
We got you covered, Jenny. Thanks for the reminder.
Thank you, Reid.
Houston, seat 4, comm check.
Seat 4, we have you loud and clear. How me?
I have you the same.
Houston Integrity, C3, comm check.
Seat 3, welcome to the party. We have you loud and clear. How me?
Loud and clear, Jenny.
This is Artemis Mission Control with a mission elapsed time of 3 days, 22 hours, and 29 minutes into the flight of Orion. Currently, the crew members aboard the spacecraft are conducting the Ox suit demo. That's Orion Crew Survival System. As you can see, they have put on their international orange suits. These are worn during launch as well as during re-entry, and they would be worn if needed during a cabin depressurization. So this test is to help teams understand how those procedures would need to go should we ever encounter such an event on this or future missions. We've had 4 good communications checks with the crew members now in their suits. Both Reid Wiseman and Victor Glover are in their seats as well. They were part of a rapid don, or quickly putting on their spacesuits, while mission specialists Christina, Koch, and Jeremy Hansen were instructed to put on their suits at a normal pace.
All right, Houston, we've been on cooling for 5 minutes, so we're going to swap the QD.
Copy, thank you.
Houston Integrity, we have all PCDs stowed, so Jenny, you got the lead.
Copy, all PCDs stowed. Once Jeremy and Christina are complete, we can ensure that their Cobra fittings are connected, and then we can move on to leak checks.
This is Artemis Mission Control. The crew aboard the Orion spacecraft, Reid, Wiseman, Victor Glover, Christina, Koch, and Jeremy Hansen, continue through the Ox suit demo. That's the Orion Crew Survival System suit. Those orange suits you see the crew in now. Both Commander Reid Wiseman and pilot Victor Glover have ingressed or gotten into their seats. They have also performed comm checks and suit leak checks. Mission specialists Christina, Koch, and Jeremy Hansen donned or put on their suits in a normal speed, whereas our commander and pilot were asked to do so at a rapid speed. They have also completed communications checks. The crew wears these suits during launch and return to Earth. They are not expected to wear them during the flight. However, they would be available for use during the event of a cabin depressurization. They could provide up to 6 days of a breathable environment for this crew member. So given that this is a test flight, we are taking the opportunity to test how they would get into these suits and pressurize them during that situation. As you can see, those suits are pressurized a little bit, how they've expanded. The crew is conducting leak checks aboard those suits right now.
Houston, all 4 suits, leak check complete.
Copy, we see the same.
And Jenny, I think now you want us back in the DFTO procedure, correct?
Affirm. We have you back in the aux suit DFTO procedure. You've just performed your leak checks. The next step should be for the LCGQD, which you've already completed, and then you will get into some commanding in the suit DFTO vehicle config.
Yeah, what step in aux suit DFTO should we be in?
Step 5.7, moving into 5.8. That's instruction 52 in the aux suit DFTO.
Okay, we're in 5.7.
Copy. That's a good spot.
That's the voice of Commander Reid Wiseman speaking from the Orion spacecraft. They are conducting the aux suit DFTO. That's Orion Crew Survival System suit. We just had confirmation all 4 suit leak checks are complete.
All right, Jenny, we are in 5.8. We're going to 22.2.199, steps 1 through 12.
That's the right place to go. Thank you.
All of the numbers you hear reported by the ground team and the crew are in reference to a specific set of procedures. This helps keep...
Before we start pressurizing, I don't have any awareness of timeline and next steps. So before we go visors down and pressurize, why don't we get a quick crew sync?
Copy. Stand by 1.
Again, all the numbers you hear, the crew calling down or the ground calling up, keep everyone on the same timeline as they are referencing the same set of procedures throughout this demonstration.
And Integrity crew, we are still talking about what objectives we are going to complete with a shortened timeline. We do want to keep the controlled depress in place because we want to get ranging data in time for OTC3. So we are talking a pared down objective timeline for you. IVA is just getting it together, so we'd like to proceed with the suit DFTO vehicle config, and I'll have words for you soon, but you can all expect a shortened timeline.
Okay, we're getting into 22.2.199.
Copy and concur. Integrity crew, Houston, we are having some discussions here on the ground and coming up with your forward timeline. We want to make sure you're not waiting for us and you are ready to proceed with visors closed when you are ready.
All right, Houston, we're picking up in instruction 21 now.
We copy.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas, with a mission elapsed time of 3 days, 22 hours. 3 days and counting up to 23 hours. The crew aboard the Orion spacecraft is currently in one of their main timelined activities for today. That's the OX suit demo. OX stands for Orion Crew Survival System. Those are the orange suits you see the crew in now. They're also the suits that they wore on launch and that you'll see again in re-entry. All 4 crew members are now in their suits and have completed suit comm check and leak checks. Next up, we will be pressurizing the suits. We are going to pressurize those to 4.3 psi. Again, this is all in support of future missions to the moon. These suits could be worn.
All right, Jenny, we're in the purge. How's everything looking on your end?
It's looking great. Continue.
These suits could be worn in the event of a depressurization aboard the Orion spacecraft, and today gives us the opportunity to learn how they would get into their suits while in the microgravity environment, and of course, get in their seats for a return home. Also on the timeline for today is the OTC-3 burn. We expect that around 10:03 p.m. Central Time today. This is a small burn with the reaction control system thrusters on the spacecraft, and OTC stands for Outbound Trajectory Correction. We schedule these throughout the mission in case we need to refine our path around the moon and on the way back home. We canceled the first 2 outbound trajectory correction burns, deeming them not necessary ahead of today. We are going to keep the OTC-3 burn on the timeline for this afternoon, ahead of tomorrow's lunar flyby.
Integrity crew, everything is still looking really good down here. We're loving getting this data. I plan to reconfigure you to be Vox before increasing your suit pressure. Let me know if you want to be Vox earlier so you can stop pushing buttons.
We'll continue in this mode for now until the pressure goes up.
Copy. We'll let you know when that's about to happen and when we do a reconfig of your Vox.
In Houston, our suit Delta P is dropping in the purge here. Is that expected?
Checking. Reid, this is expected. We are in the last 45 seconds of the purge where the pressure will decrease in your suits.
Okay, we're in finish up 3.2 now, moving to step 4.
Copy. We see you there.
And Jenny, in step 4.3, performing the purge to the cabin, confirm you want this short purge, short cabin sequence?
Affirm.
Copy that, that's going in.
Integrity crew, 2 minutes left on the purge.
We're watching. Houston, we're in 4.6, checking with you prior to proceeding.
Copy, we're talking. And Integrity, we need a minute or two here to talk the forward plan. We expect to just take a couple minutes more, but I'll be back with you shortly. Let's sit tight for now, please.
Sounds good.
All right, Integrity crew, thanks for your patience. We've had a discussion down here, and we have decided to defer the controlled cabin depress to 10-2, which was after the suit DFTO, to later in the mission, so that we can prioritize getting our objectives done while you are suited and pressurized. When you are ready, we plan to take you to Vox before proceeding with the next step. And I want to let you know that when you're uncomfortable commanding, please let us know and we will take over, else we expect to take over by step 10 in this procedure.
Okay, Jenny, sounds great, and we are ready for Vox.
Copy. We will put Vox in work. All right, Integrity crew, you are Voxed and go to continue with the procedure. Pick up in step 5.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. Currently, the teams on the ground are increasing pressure in the Orion Crew Survival System suits. Currently, their audio is only available to teams here on the ground in Mission Control. We want them to be able to transparently describe what they are experiencing as they move through their procedures. As you can see, our 4 crew members aboard Orion are currently seated and, they are currently suited. 2 are in their seats. That would be Commander Reid Wiseman and pilot Jeremy Hansen. They are stepping through the procedures of the Orion Crew Survival System demo. This is to test how the suits would perform if we were in a depressurization event and the crew needed to get into their suits in order to have a breathable environment. We did have good suit leak checks on all 4 suits, as well as communication checks. However, communications with the crew right now is only available here in Mission Control. We want the crew to be able to speak transparently about how they are stepping through these procedures. As part of this test, we have vented some of the cabin pressure overboard. It is now 11.0 psi inside the cabin. Currently, the cabin is pressurized at 11.1 psi and the suits are at 3.8 psi. When suits are pressurized, it makes it more difficult for the crew to work in the cabin. Therefore, they agreed that the ground is able to take over commanding in the spacecraft. Again, today we are conducting a demonstration of these crew survival system suits. Now that the suits are pressurized, it can be more difficult for the astronauts to maneuver about the cabin. They are obviously also connected to umbilicals, which make another hurdle into moving around the spacecraft. As previously mentioned, we are in the Orion Crew Survival System suit demonstration. The crew would need to get into these suits in the event of a depressurization of the spacecraft. They'd be able to stay in these suits for up to 6 days in a breathable environment. Pressurized suits, however, do make it a little more difficult to conduct tasks and move about the cabin. For this demonstration, the ground has agreed they will decrease the pressure in both Commander Reid Wiseman and Pilot Victor Glover's suits slightly to help them get out of their seats and conduct some other tasks. Again, you're not hearing their communications right now. That's just coming to Mission Control Houston to allow them to speak, to allow the astronauts to speak openly with the flight controllers here. This is Artemis Mission Control, now 3 days, 23 hours, and 36 minutes since the launch of Orion atop the Space Launch System spacecraft. This is a live view inside Orion. Our 4 crew members are currently conducting an Ox suit demo, Orion Crew Survival Suit System. These are the suits that the crew wears during launch and will wear again during re-entry, and they would have the opportunity to use these if needed during a cabin depressurization. Being in these suits would provide the crew with up to 6 days of a safe breathing environment. Being that this is a test flight, it's our first opportunity for the crew to get into these suits while in a microgravity environment. This is helping us prepare for future missions around the moon with Artemis, as well as for the end of this own mission when the crew will need to get suited up ahead of their journey home. Crew audio is currently only available in Mission Control Houston, allowing the crew members to speak extemporaneously with the ground control teams. There are some plans for the crew to conduct tasks while in their suits today. Currently, the team is lowering the pressure slightly in Commander Reid Wiseman and Pilot Victor Glover's suits to allow them to more easily get out of their seats. When suits are pressurized, it does make it more difficult to move about the cabin and accomplish some of the tasks we're looking to do today. Here in Mission Control Houston, teams continue lowering the pressure inside Commander Reid Wiseman and pilot Victor Glover's suits during this demonstration test. This should help them be able to maneuver out of their seats and get to work on some of the tasks we hope to see them accomplish while they are suited. You're looking at a live view inside the Orion spacecraft. The spacecraft and crew are on flight day 5, now 52,600 miles from the moon. They are 223,909 miles away from us all on Earth. Currently, our crew members are stepping through the Orion Crew Survival System suit procedures. This is a test of the suits while they are pressurized on the Orion spacecraft. These suits serve as the launch and re-entry suits for the crew. You probably saw them in this international orange on launch day. However, these suits, as is listed in their name, survival, are also available for survival situations. If the cabin were to be depressurized, these suits could provide the crew with breathing air for 6 days. This is a test flight, and so we are using this day as a test of these suits in such an environment. Now they are depressurizing Victor Glover and Reid Wiseman suits just a little bit more to allow them to move out of their seats. When the suits are pressurized, it makes it more difficult to move inside the spacecraft. We have some other tasks we hope to see the crew complete today, including using the pill tool. There is a small port on the side of the helmet where the astronauts can insert what looks like a straw and allows them to take medicine if needed while they would be in this situation. Of course, any pill taken today is simply a placebo for the purposes of the test. We also hope to see them eat and drink through that same port. This is one of the biggest parts of their timeline today. However, we do anticipate the outbound trajectory correction burn this evening actually, at 10:03 p.m. Central Time. This will be using the reaction control system thrusters on the spacecraft. These trajectory correction burns are simply refinements of Orion's flight path. We did cancel the first 2 of those as we felt like they were not needed following the translunar injection burn. But this will help us further refine our trajectory ahead of tomorrow's lunar flyby. Crew communications right now is only coming to Mission Control Houston. As we are testing this out for the very first time, we want the crew to be able to share transparently what steps they are moving through and what they're experiencing while in these suits. Once this demonstration is complete, we will make sure to put their audio back on the broadcast. This is Artemis Mission Control, and we continue to monitor this Ox suit demo. Meanwhile, teams at Johnson Space Center and Mission Management are preparing for today's mission status briefing. If you're watching on NASA's YouTube, you can stay right here. You'll be able to see that live. If you are interested in solar array wing views, you can tune in on our other stream. That's where commentary will continue. Again, standing by, that mission status briefing is scheduled to start in 4 minutes at 5:30 p.m. Central Time.
Artemis II mission is a test mission of the Orion space capsule.
Artemis II will be the first time we put humans on this rocket.
We're going back to the moon because it's the next step in our journey to Mars.
We were always going to the moon.
Pushing ourselves to explore is just core to who we are. That's a part of being a human.
And liftoff. We shall return.
Continuing to test out every bit of Orion.
Coming back to Earth, 7 miles a second.
When humanity sets big goals, we can bring together genius from around the world.
You have the best people on planet Earth putting this vehicle together.
That's what's up.
To innovate for the benefit of humanity and to inspire the world through discovery.
And here we go.
Good evening and welcome to NASA's Johnson Space Center in Houston, and welcome to our Artemis II status update. I'm Rachel Kraft with NASA Communications, and we're joined this evening by several NASA leaders to share an update on how the test flight is going overall as the crew gets ready to fly by the moon. They are Dr. Lori Glaze, who leads NASA's Artemis program, Rick Henfling, Flight Director for the mission, and Kelsey Young, Artemis II Lunar Science Lead. We'll have some opening remarks from each of our participants, and then we'll go ahead and take questions both here and in the room and on the phone line. And as a reminder to those who are joining by phone, you can press *1 to enter the question queue. And with that, we'll start with Lori.
Great. Thank you so much, Rachel. And thank you to everyone that's joining us today and for your continued interest in Artemis II. Our mission continues to go incredibly well. Our crew is healthy as we prepare and gear up to fly by the moon tomorrow. We're all extremely excited for tomorrow. We got a couple of great images that I want to share with you today, along with all of the great stuff that's available online. But we've got a few things I wanted to share this evening. We have a short video with some of what yesterday included. If we could pull up this video, it's got a lot of cool information in it. Can we see that?
This is Artemis Mission Control. You're getting a live look inside the Orion spacecraft, named Integrity by the Artemis II crew.
This is a magnificent accomplishment to be up here, to see the moon, to see the Earth, and to know that we are between those two celestial bodies, and you can see it when you look out the window. The Earth is almost in full eclipse, the moon is almost in full daylight, and the only way you could get that view is to be halfway between the two entities. It is truly awe-inspiring up here.
And Houston, we have some Earth and Moon viewers here who are putting in requests for different motions so that they can see things in the window.
We're seeing them in the camera views, and we're enjoying it. Look at those scientists go.
And Jackie, we got Jeremy on there just for a minute before his PAO event. He's just got to look at this. As soon as I put my hands on the 400, it's just... You know, I'm not one for hyperbole, but it's the only thing I could come up with. Just seeing Tycho, there's mountains to the north. You can see Copernicus, Rainier Gamma. It's just everything from the training, but in 3 dimension and absolutely unbelievable. This is incredible.
Kathy Moonjoy.
In Houston, I can tell you that Christina now has the 400 millimeter, and she also is the queen of hyperbole. It's incredible.
Kathy, Christina doing her best Reid impression at the window.
I love that. And I also really love how they talk about being able to see in 3 dimensions. Just helps remind us all that what we can do with our amazing human eyes is be able to see in stereo vision and get that depth perception. It's just wonderful to hear them talking through what their observations are. And I'm sure you'll hear from Kelsey about how well they've learned all their training, being able to tell us exactly the features they're looking at. We also woke up the crew today with a short a message from Apollo astronaut Charlie Duke cheering them on, and I think we get to listen to that here. Is that available?
3, 2, 1.
Hello, Reid. Victor, Christina, and Jeremy. This is Apollo 16 astronaut Charlie Duke. John Young and I landed on the moon in 1972 in the lunar module we named Orion. I'm glad to see a different kind of Orion helping return humans to the moon as America charts the course to the lunar surface. Below you on the moon is a photo of my family. I pray it reminds you that we in America and all of the world are cheering you on. Thanks to you and the whole team on the ground for building on our Apollo legacy with Artemis. Godspeed and safe travels home.
Wonderful. And then I had one last image there I think I saw come up for just a moment. This was another picture of Earth from Orion's window, and it really gives you a sense of just how far away the crew is from Earth. This was taken earlier today by Christina. I just think it's beautiful. So we're really gearing up now for what's going to be an exciting lunar flyby tomorrow. Our flight operations team and our science team are ready for the first lunar flyby in more than 50 years. I know you guys have asked questions, and we've heard them over and over again, lots of questions about what's so special about the moon. And just wanted to say a couple words. You know, the moon and the Earth are fundamentally made of the same material. You know, in the way back, the Earth, the former proto-Earth, was hit by a Mars-sized object, a massive collision that left lots of debris out in space that then coalesced into what is now Earth and Moon. So our whole Earth-Moon system literally is made up of the same materials. And so although Earth has gone through lots of evolution with plate tectonics and weathering, you know, the Moon has been there as a witness plate to see everything that's happened over the 4.5 billion years that we've been around. So very cool. So we're really excited to fly by and get to take these observations. Particularly having humans on board really complements the robotic exploration that goes on from NASA. They're definitely not mutually exclusive. We're working together hand in hand to grow our knowledge of what we know about the Earth and Moon system. There's a lot of science on this mission, not just the observations that you hear about from Kelsey, but our human health studies, such as the Avatar experiment that's being carried on board. All of these human health experiments are informing how we can keep our crews healthy on the longer missions that are coming up in the future. This mission is also the first opportunity we have for our science and engineering teams to work together in real time while our crew is at the moon. And I think this is another key piece of the science that we're doing on this mission is not just the observations, but learning how to work together between our flight operations and our science evaluation room and the crew. This is a really good example and a good test case to work through some of those things that we're going to need absolutely critically when we send our crew to the surface of the moon. It will also inform how we operate on the moon's surface during our future Artemis missions, and a great example of how everything that we're learning on this mission is going to feed forward to our longer-term presence on the moon. So with that, I'm going to pass it over to Rick.
Thank you, Lori. I wanted to open by wishing everyone a happy Easter, and on behalf of the flight operations team, thanks again for your continued interest in our mission. Yesterday, the flight crew finished up their day with a manual piloting activity where they took the spacecraft into 6 degrees of freedom, 3 degrees of freedom, and then we purposely deselected a few thrusters to characterize the performance of the spacecraft with some thrusters disabled. We also performed a public affairs event with the Canadian Space Agency. We had a couple of routine medical conferences. The flight crew reviewed the science plan that our science team has put together for them. And then we also performed a few activities to help characterize the carbon dioxide removal capability of Orion. When we did a few back-to-back exercise sessions, we wanted to understand just how capable the CO2 removal system was, and the results have been very favorable to date. Today, the astronauts started their day with an opportunity to put their orange launch and entry suits back on. You can imagine that when you put your orange launch and entry suit on in 1G back in Florida, it's a lot different when you try to put it on in zero gravity. And so we gave the crew a chance to practice that before they have to do it on entry day. And since the crew were wearing their orange suits, we also used this time today to practice a few contingency scenarios where they may, if they had to spend extended time in those orange suits, how would they practice drinking their protein shake or delivering medication? And how would you set up the seats in Orion while you're wearing the bulky suits? These are things that they would need to do in a contingency, and we wanted to be able to practice these before if we found ourselves in a scenario where we would need to do them. Once we finish the suited operations, we're going to turn our focus towards trajectory correction maneuvers. We're going to perform the outbound trajectory correction maneuver number 3. This is actually going to be the first one that we actually do. We found that Orion was on such a pinpoint trajectory that we didn't need to do the first 2 correction maneuvers. The one today we're going to do later on is 9.9 feet per second. It'll take about 14 seconds, and it's going to use the auxiliary thrusters on the Orion service module. We have a few other medical conferences later today. We're going to do a demonstration of in-flight maintenance where we remove one of the panels of Orion to demonstrate that you know, if we needed to get back behind one of the Orion spacecraft panels, we could do so and maybe perform a maintenance activity if we needed to. And then while the crew's asleep, we're going to perform a demonstration on the ground using our optical comm system. We're going to increase the bandwidth to 100 megabits per second using our optical comm system and our ground station in White Sands, New Mexico. The most exciting portion of the overnight hours here on Earth is going to be when Orion enters the lunar sphere of influence at 12:40 a.m. Eastern Time. That is significant because that's when the moon's gravity has a stronger pull over the Orion spacecraft than Earth's gravity. And so that's a significant milestone on our mission. I also wanted to comment a little bit about my console activities. I worked the past 3 days as the lead of the planning shift on console and mission control, and I just wanted to highlight the exceptional job that those teams are doing a few hundred yards away here in mission control. The planning team is in charge of making sure all of the operational products are ready for the flight crew when they wake up in the morning. They're also in charge of executing some test objectives and activities to gather data on how Orion performs as it heads out to the moon. And I just wanted to highlight just what an exceptional job that team's been doing. And one of the highlights of working the planning shift, we saw the photo that Lori showed a few minutes ago. We gathered around the console when we downlinked that image, and the planning shift is the group of about 10 people who get to see that image for the first time. So before any of the public got to see those images that you saw on social media, my planning team working the overnight hours while the crew's asleep, we were the first ones on planet Earth to see those images. So it's a pretty special time. I wanted to end my remarks with showing a video of some remarks from our pilot, Victor Glover, which I thought were particularly poignant and were worth repeating. And so let's go ahead and play that video.
In all of this emptiness, this is a whole bunch of nothing, this thing we call the universe. You have this oasis, this beautiful place that we get to exist together. I think as we go into Easter Sunday, thinking about, you know, all the cultures all around the world, whether you celebrate it or not, whether you believe in God or not, this is an opportunity for us to remember where we are, who we are, and that we are the same thing and that we got to get through this together.
All right, and that is the conclusion of my remarks. I'll hand over to our lead science officer, Kelsey Young.
Hard act to follow, both Rick and Victor. I will say, you know, I think the copy Moonjoy is going to be like my new motto, copy Moonjoy. Speaking of which, we are coming up on the flyby tomorrow. We're getting really, really excited to hear the crew observations. We've heard some observations, Lori highlighted them, from when the moon was much smaller out the window than it's going to be tomorrow. And even those observations had a lot of science value that's already got our lunar science team churning in the background. So really excited for several straight hours of those tomorrow, and I'll talk today about what that's going to look like. In the last 24 hours since I was last here, our lunar science team completed the lunar targeting plan, which is essentially the plan, the piece of software that the crew will follow during the several-hour flyby. If you could actually bring up the screenshot of that lunar targeting plan. This is what's going to guide the crew's observations during the flyby. It is just a guide. They are the field scientists, and they are encouraged to, go off book if what they're seeing in front of them really compels them. We've even built in targets specifically for crew choice, where they can really image what pops out to them. And so what you see here is what the crew will be looking at for the entirety of the flyby tomorrow. You see on the left side a list of sort of targets that listed vertically in the top left of the screen. Those are the targets in the timelined order we're asking them to image them in. And they're in a specific order because ultimately these targets trace back to our lunar science objectives. We have 10 lunar science objectives for this mission. All of them are covered in the targets in tomorrow's targeting plan, and they're in that order down the left side that you can see. The bottom left has the words that explain the significance of the target, as well as the prompts of what we're asking the crew to image and describe. So we have distinct prompts for the person that will be using the camera that's outfitted with an 80 to 400 millimeter zoom lens. And then we also have prompts for the person that's going to be looking at the moon at the time with the unaided eye, just using their eyes to describe what they see. Along the bottom is a cue card as a reminder of what should go into their science descriptions. I would expect they're not going to need to reference the cue card that much because they've had many, many months to practice giving good descriptions. And then, of course, the middle, the moon, the picture of the moon, this is to help guide them into the specific target that they're going to be describing and imaging at the time. You see specific labels called out to help them, provide geographic references for their descriptions. And you also see the previous target and the next target highlighted in different colors. So this is the piece of software that the crew will be looking at. And if you go to the next picture, Rick referenced yesterday that one of the activities that the crew did yesterday was to review that plan. And we just totally oohed and awed in the science evaluation room when we saw them studying in Orion. So there is Victor Glover studying the lunar targeting plan on his tablet, his crew tablet. All 4 crew had time to study that yesterday, and they'll also have a little bit of time to review it tomorrow morning. Got some questions yesterday on how the crew trained, so I just wanted to show a couple images to highlight that. So the first image is actually when they got the flight-like hardware, the 2 Nikon cameras that will form the basis of the bulk of their flyby tomorrow. And we actually put visualizations of the moon at the right distance away from them in a facility over in Building 36 here at the Johnson Space Center, and actually had them practice giving descriptions and taking pictures. We actually did that several times with them. And if you go to the next chart, we also put them in and near the Orion mock-up, the medium fidelity mock-up we have here at the Space Vehicle mock-up facility here at the Johnson Space Center, and actually had them get inside of Orion and actually look out the window at a giant inflatable moon globe we hung from the ceiling, so they could practice that physical choreography they needed to inside of Orion before their flyby. And so the last thing that I'll end with is actually showing a video that I showed yesterday. So if you could play that. This is tomorrow's flyby in 60 seconds. So what tomorrow will look like is a roughly 5-hour period where the crew will be observing the illuminated surface of the moon. In response to the question I got yesterday, the 2 Apollo sites they'll be able to see here at the beginning are the Apollo 12 and 14 landing sites. As they progress through the several-hour period where the moon is illuminated, they'll continue to work through that targeting plan. Again, each target is based on our lunar science objectives, and they'll be able to see how the moon is changing throughout their time observing it. They, of course, will have a period that you can find the exact timing on NASA's websites, and we have it here as well, where there's a loss of signal after Earth disappears from view and before it reappears in Earthrise on the other side. They'll continue their science observations during that time. Then, of course, about an hour later, we have this really unique opportunity to observe an eclipse from the vantage point of Orion, where the sun disappears behind the moon from the vantage point of the Integrity crew, and they'll be able to observe the solar corona, but right around sunset and sunrise. They'll also be able to take pictures of several planets that will be visible in view. That includes Earth, of course, Mercury, Venus, Mars, and Saturn. They'll also be able to look for potential Earth shine effects, which is literally the illuminated Earth shedding glow onto the near side of the moon. We've got a jam-packed plan for them tomorrow, and it ultimately all traces to our science objectives. Thanks.
All right, we'll now take questions. We'll begin here in the room. We'll also take some from the phone. A reminder, you can press *1 to get into the question queue. Please limit your question to one at a time, and let's wait for the mic to come around. We can start here with Jackie.
Hi, Jackie Waddle, CNN. Question for Kelsey. I understand during the flyby they're going to be focused on that Oriental basin, but we've also heard about the importance of these precursor missions to a landing, about scouting possible landing locations. And I know that, the overarching premise here is to establish a base on the South Pole. Can you talk a little bit about what the crew will be looking for in terms of gathering data for those long-term goals?
Absolutely. So that is one of our science objectives, actually, is past and future landing sites. And so, like I said, they'll be able to see, in terms of past landing sites, Apollo 12 and 14. They'll also be able to, kind of on their transit from near side to far side, be able to see Reiner Gamma. That's a target in their lunar targeting plan. That's a really exciting sort of lunar science unknown, a big question that's actually driving Eclipse landed mission there, where we'll actually land scientific instruments on the surface to evaluate this really unique feature. And then moving to the far side, of course, we are going to have eyes on the South Polar region. Because of the illumination that they'll experience tomorrow, they'll only be able to see kind of the edge of the South Polar region in the South Pole Aitken Basin, but it will be a target for them to observe what they can see along the Terminator.
Okay, Tarek, go ahead.
Thank you. Tarek Malik with Space.com, also for Dr. Young. 7 hours for a flyby seems like a long time, and a lot of training has gone into this, and I'm curious what the pace is going to be like, both for the crew on the way in and for your team in the operations room, and how you make sure that everyone is staying focused and yet kind of in it for the duration for, I guess, all of the different phases of the flyby.
Yeah, what a wonderful question. Thank you. So we actually did work on that kind of choreography and mental loading with the crew. And so we initially, months ago, started with targets at a cadence of only 5 or 6 minutes. That was pretty fast. And it didn't really allow them time to kind of like settle into the observation. What we've already seen from their observations so far in flight is that the longer they look at the moon, the more their eyes adjust and the more they're able to discern. So we wanted to allow time per target for them to settle into that observation, because ultimately that's going to deliver the most science. So the quickest time per target tomorrow will be roughly 8 minutes, and some of the targets, which are kind of crew discussion focused, are longer, on the order of 20 minutes. They also, how the sort of flyby choreography will work is, for that first 5-hour period, they will work in pairs. So Reid and Jeremy will observe first, while Victor and Christina are doing other tasks and also helping the pair at the forward windows. And then just over an hour later, they'll swap. And so in that way, they kind of can keep fresh with what they're doing. In the middle of each block, so when Reid and Jeremy are at windows 2 and 3 observing the moon, they'll actually swap who is doing the imaging and who is doing the unaided eye descriptions. So they're really able, in this first big 5-hour chunk, to really mix it up and work through the targets kind of one by one. I will say, our science officer team did practice it as well for that number of hours, with the representative target length. So we really got a sense for kind of what they're going to be experiencing. And then they do have kind of an hour break in the middle where the vehicle actually points back to its bias tail to sun attitude before pivoting back for the eclipse. So it's kind of like a little lunar science mental break. I also want to highlight something Lori said earlier, which is that we have lunar science objectives we want to tackle with this mission, but this is the first mission, right? And we really want to learn about the choreography of all of this, between the ground team supporting all the way up to the crew. And when we think about surface missions with EVAs, with science objectives, we really do need to get used to this sort of mental loading and how we're able to support the crew and not, overburden them while still maximizing science. So I'm really excited about kind of this length of time that is relevant for hopeful future exploration and what we're able to learn there. And then the last part of your question about the science team, thanks for asking. The lunar science team will be in the science evaluation room. I know that the live broadcast tomorrow will flash to them occasionally throughout the broadcast. You're going to see some very excited scientists. They're going to be absolutely buzzing up there. And what they're going to be doing is monitoring the crew, of course. The crew will be giving several descriptions an hour, roughly 3 to 4 lunar descriptions an hour, and the science team will get to work right away, kind of synthesizing those, and then we'll actually downlink the rest of the descriptions overnight in advance of a crew conference we'll have the following morning to, again, continue the science discussion. And so the lunar science team is going to be both really excited and then also trying to keep track of the science through those, what we call science sit reps.
Okay, Gina.
Gina Sinceri, CBS News. We know the crew is shooting a film camera. When that film comes back, where is it processed, and how will you be able to turn those images around?
The crew-operated cameras, there'll be actually 3 of them for tomorrow's flyby, 2 Nikon D5s and 1 Nikon Z9. The 2 Nikon D5s will have the 80 to 400 millimeter zoom lens. That's going to be the prime imaging lens for the bulk of the flyby. There's also a 14 to 24 millimeter lens that we're going to be using during the eclipse timeframe. And then the Z9 camera will be especially used around the time of sunset and sunrise for the corona. And actually what we will do is downlink as many images as possible overnight and throughout the rest of the mission, of course, as bandwidth and downlink potential allows. And of course, we'll be getting some out to the public as soon as we possibly can. But the rest that we don't downlink in flight, we'll get once they splash down, and we'll have a team that brings the cameras and the flashcards back to Houston pretty quickly and gets them in the pipeline to release all of them out to the public.
Go ahead.
Thank you for your time today. Ed Lavandera with CNN. 2 questions. Watching the crew today get into the spacesuits and reconfigure the seats, it seemed very difficult, or it takes a long time. Is there ever a situation where is the speed at which they did that today pretty good? Is it something that needs to be done faster in the future? And then the second question is, when the crew in the capsule is going around the moon, and at least to someone like me sees it, it's almost like they're hooking back quickly. Are they going to feel like they're turning back? Is that a sensation that they're going to have when they're inside the capsule?
I'll take the first one, and maybe Kelsey could take the second one. In terms of the suit donning that we did today, the speed is not particularly something we are concerned about, because the Orion spacecraft has the capability to feed a cabin leak, to buy the crew the time to put the suits on. It's not something where if we had a strike that punctured a hole in the cabin, that the crew wouldn't have time to put the suits on. We have oxygen loaded on the spacecraft, and that oxygen will be continually providing cabin pressure, maintaining 8 psi in the cabin to allow the crew that opportunity to get their suits on safely.
And I think we'll have to ask the crew tomorrow what they can and cannot feel, but I can tell you what they're going to see. And we had, a lot of conversations when we started scoping the flyby about how fast are they going to be moving? Are they going to have time to see some of these smaller scale features during the flyby? And so we have an amazing visualization lead for the mission, Ernie Wright from the Goddard Space Flight Center, and he has done just amazing work to really try to reproduce as close as possible the illumination conditions they can expect at the speed that it will be moving. And it actually, from the perspective of the spacecraft, they will be moving slow enough to really be able to make robust observations. So it was quite a relief to our team and definitely to the crew when we started playing these visualizations. I don't know what they're going to feel, but I know what they're going to see, and they're going to have time to make observations. Go ahead.
Hi, Michael Atkinson, Houston Public Media. I want to ask about public engagement. I think that in the social media age, it's a lot harder to keep people's attention compared to the Apollo era when there was just 3 TV channels. I'm curious what you guys have made of public engagement thus far and what a successful day tomorrow looks like. I understand it's going to be streaming on a lot of different outlets. What would a successful lunar flyby from the public engagement perspective look like?
That's a really great question. I can assure you that we are tracking the metrics very closely every day, absolutely, and the public engagement has been spectacular. It has, I think, dropped a little bit since the launch day, but I do anticipate a big bump again tomorrow as we have this really key moment in time where we're flying around, we're breaking the Apollo record, we're going to have an eclipse, we're going to have all of these amazing observations. I really think we're going to get another big spike. I'm really looking forward to that. And then I anticipate another big spike when we splash down on Friday evening.
Yeah, I might add to that too that, first of all, I might turn the question back around on all of you and say that, our public engagement team has done such an amazing job to package messaging about this mission, and specifically the lunar science engagement team has been working for months and months and months to make sure that the public has access to the information about the moon. But please help us, right? This is a unifying moment for all of us, and we really, we've put our best foot forward into preparing this mission for success, and we know what it's going to mean to connect to the moon in that way tomorrow. And please, all of you in the room and online, please help us get the word out. Okay, go ahead.
Hi, TG Mosquero with the Epoch Times. Thanks for taking the time, and happy Easter. Question for Rick and Lori. Without a landing or parking in orbit, what are you considering the official arrival point? Like when you arrive at the moon? Is it when Orion enters lunar gravity? Is it when the flyby begins? Is it the closest point?
Well, I'm looking at Rick here, but from my perspective, as Rick said earlier, when we enter that point where we cross over from being driven by Earth's gravity to being pulled by the moon more strongly than Earth, to me, that's where we'd start. But
I think I was going to give the same answer, so I agree.
I'll give the lunar science example, which is closest approach.
Everybody's point of view.
Okay, go ahead.
Hi, Alejandro Turnbull for Space Scout. Question for Kelsey. Looking forward to future Artemis missions, how are you expecting the science plans to change from what we're going to see tomorrow? What opportunities are going to be afforded to you by having crew both on the surface and in orbit?
Oh my gosh, great question. We're learning a lot about the flyby and orbital observations piece of Artemis missions from Artemis II, and we're looking forward to learning more with Artemis III, right? But looking to the future, when we do have crew on the surface and crew in orbit, of course, those sort of concurrent observations hold a lot of value. Different vantage points tell you something different scientifically, and having that sort of orbital view from Orion, from an orbiting spacecraft, around the time when the crew is on the surface does enable these really important contextual observations, especially that orbiting crew that's going to be farther away is really going to be able to say, these geologic processes influence the landing area, and that's going to help us tell the story of the science of the mission, and ultimately could impact what type of samples we're asking future crews to collect. And for the payloads that we deploy on the surface, let's provide that landing site contextually in where they landed on the moon. A lot of science value to be gained both from surface science and from concurrent observations.
Okay, let's take one from Ken, and then we'll go to the phone for a few.
Hi, Ken Chang from New York Times. A couple questions for Kelsey following up. So you said they're going very quickly over the far side. Do you know what the maximum speed is relative to the surface? And just sort of following up on what you all will be doing down here. I remember a media tour last fall, you had this wonderful table that you'd be seeing, having interactive. Will you be giving feedback to the astronauts or follow-up questions, or you don't want to interrupt them what they're doing?
Great question. Do you know I don't know the rate.
I do not. We'd have to check on that and get back to you.
Yeah. Yes, the science evaluation room is a really exciting room. We worked with Mission Control to develop this unique flight control room for the mission, specifically with science in mind. It's not a traditional flight control room that has, typically like rows of consoles where disciplines are plugged in with their teams. Scientists like to talk, and they like to talk over airwaves, so we've allowed for that in the science evaluation room. And what you're referencing here is a beautiful smart table where you can actually, and it's a touch table, right, where you can, put up data of the moon and zoom around different areas of the moon to kind of follow along with what the crew are doing. But we will be engaging with them during the flyby, of course, with the exception of the time when there is that planned loss of signal. And we do plan to be following up on their observation. So again, these 4 people are absolutely ready to give scientifically valuable descriptions, but more brains can help, hone in on nuances of the observations that they're making. And so we have allowed time for crew discussion where all 4 of them at the same time will be discussing some scientific question. For example, I believe the first one tomorrow is the near side, far side transition and looking at color and albedo across that transition. They'll be discussing with each other, and I've heard them in simulations, one crew member will say something and the next crew member will say, oh, actually, I saw it this way, and they're actually able to really have elevated science discussions. But we do plan to have that interaction from the ground as well, based on what the science team in the science evaluation room is seeing and hearing from the crew. We'll be able to have a bit of a science dialogue. We have enough hours in the flyby where we'll be able to have a back and forth, which I'm really anticipating is going to enhance science return, because we have this amazing back room of lunar scientists and geologists ready to help provide support.
And it's super high tech. I can back her up. I've been in there. It's so cool. You'll get to see it, I think, during the feed tomorrow.
Okay, we'll take several from the phone now, and we'll start with Jeff Faust with Space News.
Good afternoon. Question for Rick. We heard yesterday at the briefing about a mystery smell whose source wasn't identified. It wasn't a cause for concern, but I don't know if you have any updates on whether that smell is persisting and what might be causing it. Thanks.
Sure, good question. We have been trying to correlate the smell and the crew reports of the smell to a particular event or a changing configuration of the spacecraft. We have a number of heaters that are located near that area of interest, and there's nothing about a heater cycling that we can correlate to the smell. There's nothing about the usage of the toilet that would cause an increase in the concentration to cause a more acute smell or a more mild smell. So right now, there isn't any root cause identified as to what that source is, but we're continuing to proceed with the mission and the use of the toilet nominally.
Okay, our next question is from Stephen Clark with Ars Technica.
Hi, thank you for taking my question. I think my question is probably for Rick as well. You mentioned the checkout tonight of the optical comm system on Orion. Has that been used thus far in the mission? How is it performing? And also, if it checks out and you're able to get to that 100 megabits per second downlink, will that kind of expedite the downlink of some of the photos we're expecting from tomorrow? Thanks.
Sure, yeah, the optical comm system has been performing really well throughout the mission. We've used it throughout all of the lunar transit. We have 3 sites where we downlink data. We have one in California, one in White Sands, New Mexico, and then a third site, which is kind of a test and a target of opportunity with the Australia National University in Australia. And we've been able to stream video live to that site as well. And yes, if we can get the bandwidth increased to 100 megabits per second, that will absolutely help getting imagery and data from the spacecraft down in a more timely manner.
Okay, we'll go to one more on the phone and then come back here in the room. The next question is from Sana Pashankar from Bloomberg.
Hi, thank you so much for doing this. A question for Dr. Young. Obviously, it seems like an enormous amount of thought and effort and scientific considerations have been put into preparing for the lunar flyby. I was just wondering, when did the lunar science team at NASA start making preparations for the flyby? Did it start like when the astronauts were selected in 2023 or after Artemis I? Yeah, thanks.
Yeah, thanks for the question. Not specifically for Artemis II, but for Artemis science operations in general, it's been a number of years that we've been preparing and integrating with flight operations. I will say flight operations has been incredibly welcoming. I think it's a testament to the fact that, science is one of the fundamental pillars of Artemis, and, specifically for Artemis II, Rick and Judd and Jeff have been nothing but, really, really welcoming, knowing that, of course, our destination for this mission is, of course, the moon. Specifically for Artemis II science preparations, we did, actually start working with the crew pretty quickly after they were selected, more in a classroom training environment, but that did kick off the discussions for our team about how we wanted to develop our science objectives given the mission profile characteristics as we learned more about that, about how the mission profile was evolving. And so that enabled us to really jump off on establishing our science objectives, and with me being selected as the lead for the lunar science for this mission, I was really able to build out our amazing team pulled from several different NASA centers, experts in lunar science, geology, visualization, geographic information systems, some teams here at the Johnson Space Center who supported Earth observations from the International Space Station that are actually responsible for developing that gorgeous lunar targeting plan. And so the plans for the flyby profile as we're going to execute it tomorrow probably really ramped up in earnest just over a year ago. But prior to that, there was a lot of work going in with the flight operations team for integrating our new science officer console into mission control, as well as building out the science evaluation room.
Okay, we'll come back into the phone, or pardon me, to the room. Irene, and then we'll go to Tom.
Thanks. Irene Klautz with Aviation Week. For Rick, a couple of flight operations questions. First is, which two astronauts attempted to don the suits quickly, and how much faster did that happen compared to the nominal donning? And on the manual flight demonstration, did the exercise today complete all the or maybe last night, sorry, I've lost track of days. Did that complete all of the manual operations that you're expecting, and what have you learned so far about the nuances of Orion's handling that you want to kind of continue more studies on post-flight? Thanks.
Of course, thanks for the question there. As far as who donned the suit rapidly, that was Reid and Victor. And then Christina and Jeremy donned it in the quote-unquote nominal time frame. The rapid donning was attempted to be done in about 15 minutes, which is pretty swift. And again, that corresponds with the time that Orion has to feed the leak and maintain cabin pressure before we can get the crew safely in a pressurized environment. As far as the manual piloting that we have left, we have another test on Wednesday. That will be in the crew's afternoon after they build the radiation shelter. And then finally, with respect to the handling qualities, I sat in the back of Mission Control during the proximity operations demo. I had just worked the ascent shifts, but I couldn't stay away, and I had to watch. And it was pretty spectacular to watch Orion pretty much stop on a dime. You know, Victor would deflect the hand controller, release it, and you saw the ICP, the video of the interim cryogenic propulsion stage. You'd see it move and then just stop right on a dime. And so I would say we've got some pretty well-engineered control laws on Orion.
Tom.
Hi, guys. Tom Costello with NBC News. Thanks for so many great news conferences. I have just a basic question with, I don't have a PhD in rocket science. Can you explain for the audience how it is that when it goes into the moon's gravitational pull, and then when you come around the other side, the Earth's gravitational pull can take over or becomes stronger? You help me understand that, and that would be great. And then second of all, can I just confirm with you the photographic number of targets you have, and how many photos you expect to take? Sorry if I missed that.
All right, I'll take a swing at the orbital mechanics here. So the translunar injection burn essentially raised our apogee, the height of our orbit above Earth, to a point where we target it such that the moon will, as it orbits Earth, we kind of intercept the moon and we allow the moon's gravity to take over. And then because we're not entering into lunar orbit, we coast past apogee relative to Earth, and we start falling back to Earth, and eventually the Earth's gravity is going to take over and bring the spacecraft back into the atmosphere.
As for targets,
I was just going to add one more thing to that, is that as you enter, as we talked about, the stronger influence of the moon's gravity, we're out at some distance, and so when it starts to pull on us, we go into a circular kind of an arc around the moon, and that kind of slingshots us. You can imagine a slingshot around, but then that kind of starts to overshoot and come back, and then by the time you might go somewhere else, we're now pulled into Earth's gravity again, right? So it starts to pull us back. So it's the interplay of those two gravity fields that really drive this beautiful dance of the spacecraft.
The number of targets, I'll have to get the exact number, but it's in the range of 35 targets. We actually do plan to put out the list of targets hopefully tomorrow morning so that the public can follow along. I will caveat that with that's a plan, right? And they're going to flexibly execute that plan based on what they see. But we will put out kind of the list that they have been studying too. As for number of pictures, It's a great question. The only way we can kind of make a guess at that is from the mission simulations we've done on the ground, where they're taking pictures of not the real moon. I have a feeling that the real moon is going to be a bigger draw. I would expect thousands of pictures that the crew themselves will take, not to mention the imagery that we will be taking with the Orion vehicle cameras.
Okay, we'll go here and then back to Will Robinson-Smith after that.
Hi, Emily Martin from CLS Fast Friends. Thank you so much for doing this. I was wondering, which specific science questions do you hope this flyby will will answer? The Apollo samples ultimately answered the question of the origins of the moon. What do you hope those data gathered by these human eyes will answer? And also, I was wondering if you are planning on taking a photo of Orion with LRO, if it's even feasible.
So on the science objective question, we do have 10 science objectives, all of which we feel are accomplishable, attackable by the crew with the lunar targeting plan as written. The lunar targeting plan does actually address all 10 of our objectives. But as for the ones that I'm most excited about, I am really excited for, our number one priority objective is, color provinces and albedo, right? This is something that human eyes are just incredibly good at teasing out nuances about. And again, forgive me again, the photometry deep dive, but again, the ability of a crew member to look at the surface in different illumination conditions as the Orion spacecraft is moving across the surface of the moon will allow them to understand morphology and texture, and therefore origin, process and origin. I mean, you heard even from farther away, Reid say yesterday, oh, I can see much more topography around Tycho than I could in the visualizations. As he's getting closer, he is seeing that 3D effect start to realize. And when they get even closer and they have that sort of extreme flyby profile over a number of hours, they're really going to be able to tease out that dynamic between topography, surface texture, morphology, and color and albedo, and how and if those things overlap. There are some targets on our targeting plan where that's specifically an objective of, do you see a correlation between color and topography? And a negative observation, not seeing it, is a science result, right? And so we do really focus on this unique profile that this mission has. I think we've gotten the question, well, you're so far away, what can you even do? That's actually an asset for our science objectives. They're gonna have this whole disk view, and the rate at which they're moving and the illumination changes that they'll experience in several hours enable our science. They don't detract from it. As for complementary observations, yes, we do plan to have complementary observations with the Lunar Reconnaissance Orbiter. We also have other complementary science investigations, including citizen science here from scientists on Earth who are going to be looking for impact flashes or new craters that are forming on the surface of the moon, just like the Artemis II astronauts will be looking for. So lots of chances for coordinated observations, and you can bet we'll be putting out information about that, especially the Lunar Reconnaissance Orbiter ties post-mission.
Okay, Will, and then we'll go back to the phones for a couple of additional questions.
Thank you, Rachel. Will Robinson-Smith with Spaceflight Now. Thank you all for taking the time today. Couple to Rick, if I may, about the OX demonstration. Please correct me if I'm wrong, but it sounded like at one point there was a plan to lower the cabin pressure in Orion. Can you talk about when and why that changed? And then the life limit for the astronauts in the suits we've heard is 6 days. Can you go into some detail about what the life limiter is for that? I mean, obviously the crew is now within 6 days nominally of returning to Earth, so if they needed them, they've got that latitude. But can you just go into some explanation about why the 6 days, what creates that bracket? Thank you.
Sure. You're correct that we are planning on decreasing the cabin pressure in Orion. That was always part of the plan. As we look forward to future Artemis missions, we expect lower cabin pressures when we perform dockings to other spacecraft. And we want to be able to evaluate Orion here on Artemis II to understand how it performs at 10.2 pounds per square inch atmosphere, so that when it docks to another spacecraft, we quickly equalize pressure. As far as the 144-hour constraint, that is tied to the oxygen and the ability to supply oxygen to the crew. Those tanks are only so big, and they were sized for that contingency.
Okay, we'll take several questions from the phone. Next up is Jackie Mogensen from Scientific American.
Hi, thanks for this. I was wondering, on the lunar flyby, I understand that there are a number of things that the astronauts have been training to see, but I was curious what you would say are kind of the wish list items of what would be really cool to see but are not a guarantee. Thank you.
Ooh, you know, I would think, honestly, a big one is just the amount of color they're going to be able to see and where and when they see it. Again, you know, negative observations, not seeing something is science. That is something we are learning. So I think we have a lot of questions about where and how subtle color hues will pop out to the crew. You know, we have guesses, of course. We have educated guesses based on what we know about the lunar surface, especially the far side, which haven't had, you know, human eyes on it before. But we don't know what to expect. We've provided guidance to them on where we think the best places are to, you know, make those observations, but this is exploration, right? And while we have imagery, amazing data from orbiting spacecraft, it's these nuanced observations that we're lacking. And so, you know, this is discovery, right? And we're asking questions that we don't always know the answer to, and that's, you know, some of the value of what these Artemis missions bring.
Next up is Marcia Smith with Space Policy Online.
Thanks so much for taking my questions. One question I think is to Rick, and could you just clarify about the toilet situation? Have you permanently fixed that, or is it that every certain number of days or something you're going to have to turn the spacecraft towards the sun in order to make sure that that vent doesn't freeze? And this is a permanent solution for this mission or for all the future Orion missions? Could you just clarify the situation on that? And on a completely different front, I'm just curious to Kelsey and to Lori, maybe wearing your planetary science hat. So when you have the astronauts looking at the far side of the moon and seeing them with their eyes, which LRO can't do, is there any chance you're going to spot something there that is so fascinating that it's going to change maybe plans for CLIPS missions or something, to send CLIPS missions there to investigate? What do you think the odds are that you'll see something that you really didn't expect?
All right. Well, as for the first part of your questions, there are no liens against use of the toilet. The crew members are able to use the toilet, but we are still trying to figure out the wastewater vent line problem. It's kind of a complex engineering issue when you expose a liquid to vacuum. It's a pretty chaotic environment, and there's a lot of theory and textbook work done when you assume it's pure water being exposed to a vacuum. But when you introduce the variable of it being wastewater, there's other complex phenomena that we don't quite yet understand that are factoring into that vent line. And so we're still working through that. This is a good opportunity to learn now on a shorter mission. And you know, if changes are needed to be made to the spacecraft, you know, we have opportunities before Artemis II to make those changes.
Let Kelsey answer the question about if you think we might see something surprising.
Rick, do you want to do it? No. You know, I think, you know, of course, we don't know what we don't know, and there's a reason. You know, I think your question kind of hits at the heart of why we explore, right? I mean, we can send reconnaissance missions to the bottoms of the ocean and to the poles and to Mars and to the outer solar system. And, you know, I like to think that planetary scientists, you know, are pretty good at their jobs and pretty good at outlining plans of what they think we will expect to see. But we in the science community like to talk about multiple working hypotheses, right? You know, we take all available data and we form these different hypotheses, and we make a plan to go address and buy down those hypotheses. And so, do we have guesses about what they're going to see on the far side? Yes. Do I have solid confidence in exactly what they're going to see? Absolutely not. That is why we, you know, why we send people out into the cosmos to explore in the first place. And so, you know, I think it's important to remember that, you know, what the crew are going to do tomorrow is the first step in this exploration. And I think it's important to remember that, you know, we don't always know exactly what they're going to see. We have lunar reconnaissance orbiting spacecraft data of the surface. We understand, you know, what it's made out of. We understand the topography, but we don't know what the crew are going to see in these specific illumination conditions from a scientific perspective, and that's exciting. It's part of the exploration mission. It's one of the main charges of the Spaceflight Agency.
Okay, we'll go there.
Thank you, Rod Pyle at Astor Magazine. This is drilling in a bit, so I apologize if I'm peeling the onion too much. This is for Kelsey. You know, during Apollo, if you look at interviews with some of the geology backroom guys, they were operating almost entirely from audio, and the video was really of low quality. So now that you've got this spectacular video imagery coming back, do you think you'll have a real-time feedback loop of evolving science targets while they're doing the pass behind the moon?
Oh.
Thank you.
My goodness, what a good question. This is going to allow me to nestle into my happy place of science and operations. So the answer to your last question of if we will have targets evolve over time, the answer is, you know, for tomorrow, we're likely not going to be, oh my gosh, scrap the back half of the plan and add in all of these new targets. However, in looking to the future, as Lori commented on right at the beginning, for future missions, when we have longer stays, both in orbit and on the lunar surface, that longer term presence will enable us to flex the plan and enable and empower the crew, you know, of course, within the requisite safety constraints, to audible scientifically about the types of samples and the types of observations they're making. And so tomorrow, the science evaluation room is going to have that future in mind, right? They're going to be listening to what the crew has to say, and they're going to be passing up follow-up questions. And, oh my gosh, we heard you notice Grimaldi. That was not one of your targets, but what you just said was amazing. While the viewing attitude still permits, could you provide some additional words? That is absolutely in scope for tomorrow, depending on what we hear from the crew. Your question also gives me a good opportunity to share with you all what tomorrow is going to look like for those of us watching here on Earth. We will see video streamed from the Orion vehicle cameras. So we will kind of see the moon at the distance that, of course, the crew can see it at. We will also, at times during the flyby, go kind of on board with them the way that we have been experiencing the last few days with that interior camera. Although, I think I mentioned this yesterday, it's going to be very dark in there. So it will not look as crisp and beautifully lit as a lot of the footage that actually Lori and Rick showed earlier today. But it will give you a sense of being on board with them. And then you are not going to hear them all the time during the flyby. You will hear several times an hour a status of how they're moving through the lunar targeting plan and giving some descriptions. Those science sit reps, as we're calling them, will not come from the prime crew that are at the windows at the time. It will come from one of the two crew members who are not, you know, plugged into their crew tablets and really down and in on the observations. It will be a third person coming to an additional window to make those descriptions. So you'll see the streamed video, you'll hear from them several times an hour, and then as soon as we can after the flyby ends, our team will be working as a part of the flight control team to get those downlink requests in quickly so we can get all the audio down and get as many images as we can overnight and then throughout the rest of the mission.
Okay.
Hi, Lisa Grossman from Science News. I have two questions for Kelsey. One is, I'm glad to hear that the target list is going to be made public tomorrow. Is that cool user interface thing that you shared an image of earlier going to be made public at any point?
We're working on how to archive that for the public after the mission. We're not going to be able to do it within the mission, but it is such a big part of lunar science in this mission. And, you know, for those familiar with the Science Mission Directorate, you'll know that, you know, we take very seriously the charter to make every every data set relevant to lunar science accessible to the public. And we have a charter to do that for this mission within 6 months post-mission. And so we will be working hard to identify how we can get this tool out to the public, given its criticality for lunar science.
Thank you. And then what phase will the Earth be in during Earthrise?
So what they will see on the Earth is Asia, Africa, and Oceania. And so for anybody listening here who is in Asia, Africa, or Oceania, you can go out and look at the near side of the moon at the exact same time that the crew will be looking at the Earth. For those of us not in those places, we can go out later and still see the same views, but for those in Asia, Africa, and Oceania, know that the crew will be smiling down on you around Earthrise and Earthset.
Okay, and we'll take one final question and then go ahead and conclude. Marcia.
Hi, Marcia Dunn, Associated Press. I'm looking for some numbers, please. What's the latest numbers on the maximum distance that Orion will be from Earth? What's the closest distance to the moon? I think I've heard 4,000 miles. And the total, the illumination for the far side, is it about 20% tomorrow? I forget the numbers. And it also, Dr. Young, take off your science hat for a moment and wax poetic about the fact that tomorrow astronauts are going to be flying around the moon for the first time in so long.
So I'll take some of your first ones here, Marcia, and make sure I get them all, so let me know if I miss some. So a little before 2 p.m. Eastern tomorrow, we're going to pass the Apollo 13 distance record by humans, and that record is 248,655 statute miles. That's when we break the record. And then tomorrow evening, around 7:07 p.m. Eastern, we will reach the farthest distance from Earth at a distance of 252,760 miles. That's 4,105 miles farther than Apollo 13. You asked about the percent of illumination. My recollection, it's close to like 21%.
Yeah, the caveat there, though, is that that is the percent of the far side that is illuminated at closest approach. So when they are closest to the moon, they will see 21% of the far side. On their approach, as you saw in that visual, they will see the full disk. It will include a big section of the near side as well as that section of the far side.
Essentially, you know, half of the moon is always illuminated.
We'll see that.
And so they will see the full 180 degrees that's illuminated as far as far side. Yeah. Thanks, Kelsey.
Yeah, I think it's at closest approach, it's 4,070 statute miles.
Mm-hmm. Yep. And then do you want to wax poetic?
Oh my gosh, of course, always. I mean, first of all, I will be on console tomorrow, so I will be locked in and fully in operations and execution mode. But, you know, sitting here today, the day before the flyby, you know, I was a kid who loved to play outdoors, and I was a kid who loved to, while playing outdoors, look up at the sky. Being outdoors and exploring the environment around me was a massive part of my childhood. I'm the mom of 2 young kids, and my youngest is right in the phase now where she looks up at the moon at night and just screams moon every time she sees it. She just stops what she's doing and points up and yells moon. And it really just, I swear I do not push her to do this. This is a natural instinct. But, you know, I think it goes to show that people all over the world connect with the moon. This is something that every single person on this planet can understand and connect with. Of course, you know, I'm focused on my kids in my house, but I know that people all over the world have their own sense of connection with the moon. Specifically, also, we will get an eclipse tomorrow, and I think everybody on Earth, or a lot of people on Earth, have connections to partial or full solar eclipses. I'm wearing my eclipse earrings today. You know, we're approaching the 2-year anniversary of the 2024 North American eclipse, which was actually the same day that my daughter was born. And so I have a lot of emotions, to be totally honest with you, wrapped up in this mission and the specific timing of this mission. And I think my overwhelming takeaway is just, yes, I'm a geologist and a planetary scientist, and I have worked with this crew for so long, and I know that the data we will get back will inspire the next generation of scientists and explorers, but it will also bring the moon closer and unite all of us, where we can have this tangible touch point to the moon and what the crew are going to be doing tomorrow. And so as a scientist and as a mom and as a citizen of this planet, I'm really looking forward to tomorrow. I hope all of you are as well.
Well, that's a wonderful way to conclude. I want to thank our participants for being here today. We're going to go ahead and pop up onto the screen a graphic showing all the events for tomorrow. Our special coverage begins at 1 p.m. Eastern and extends into the evening. Thank you for joining us today, and you can follow the latest mission updates on nasa.gov.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. Mission elapsed time for the Artemis II flight is 4 days and 58 minutes. This is the Orbit 1 team monitoring all of the systems aboard the Orion spacecraft. The crew aboard the spacecraft is wrapping up the Ox Suit DFTO, the Orion Crew Survival System Suit Demonstration Test. During this test, the crew got into their suits, and 2 of them got into their seats. This is the first time the crew has gotten suited while in microgravity, and we also pressurized their suits.
Integrity Houston, we do have big picture words to pass for you, and we see ourselves coming up on a longer LOS here, so please give us a call when it's good to pass those words on to you.
Okay, we're just getting out of suits, so go ahead now. Now's a good time.
Okay, I'm going to roll through this list with you. We have turned off the CamCab 3 because we suspected that you were suit doffing. We also don't have the HHP camera. We wanted to let you know that at our last check, it was still connected to the encoder, but it looked like it had been bumped. So we don't have that picture. We want you to check it when you are ready, aka done with your doff. Automatic cabin leak detection is enabled again. And on your timeline, we have canceled your burn conference and taken care of preliminary targeting for OTC-3 burn ops from the ground. We want you to continue your suit doff and your closeout of this procedure and look after yourselves, especially around midday meal. We also want you to know that there will be a data transfer activity for Reid in the afternoon. It's called Flywheel Excel Data Transfer. That is deferred for today.
Okay, we copy all. Jenny, we have one question on Jeremy's seat config. Can you give us the foot pan length extension for entry?
We're checking on that. I'll have it for you in a minute. While I have you, I want you to know that soon we will have some calls up to you to perform, likely on the SIP, which will get us back into a good vehicle config after suit doff. I'll be back in a minute with that setting for Jeremy's seat.
Okay, we'll wait on your call for the SIP switches.
Copy, and Jeremy's psi position is 5, and if you're talking about the CAF extension, that is fully extended. It should read 6.
All right, Jenny, he's got that seat configured. Thank you.
Finally, one more for you, Reid. If you did not use mags today, we would like you to save the unused mags.
Okay, 3 out of 4 will be saved.
Thank you.
Jenny, I don't know if we lost you yet. Just confirm we are go for secondary dump line.
Secondary. We're still with you, Reid, and we're checking.
And just make sure that we still have crew choice for toilet ops.
Affirm, the crew plan is still go for toilet, and we're checking on the secondary line. Integrity crew, you are go to use the secondary line for dumps.
Okay, sounds good, and we'll reconfigure the cut before we do that. Thanks.
Affirm, thank you.
This is Artemis Mission Control, the spacecraft now less than 50,000 miles away from the moon. Again, we are excited for lunar flyby tomorrow, the first time we've sent humans around the moon in over 50 years. So far today, the crew has completed their Ox suit demo. That's the Orion Crew Survival System suit demonstration. The Ox suits are what the crew wears during launch and re-entry for the spacecraft. However, they also have the opportunity to put these on in the event the spacecraft were to be depressurized. Of course, that's not what happened today. This was a test of these suits ahead of future missions. Everything conducted today helps us prepare for future Artemis missions to the moon. The crew is currently inside the cabin getting out of those suits, and so we are not showing those cameras at this time to allow them some privacy. But they are reconfiguring the cabin following that test. During that demonstration test, we saw all 4 crew members get in their suits, have successful suit leak checks and communications checks. Both pilot and Commander Reid Wiseman and pilot Victor Glover were able to get into their seats. And again, they are now reconfiguring the cabin and taking down the portions of the seats that they had added to help with this task. The crew will soon be moving into their midday meal period. And then later this afternoon, having the OTC 3 burn, that's Outbound Trajectory Correction 3. We did cancel OTCs 1 and 2. These small outbound trajectory correction burns help keep us on the proper trajectory for our lunar flyby and our return to Earth. The team does intend to execute today's flyby or outbound trajectory correction 3 burn. These are small burns using the reaction control system thrusters on Orion.
Integrity crew, Houston, we have a couple of items to discuss with you again before this LOS.
Go ahead.
Hey, Christina, a couple of vehicle things for you to start. First of all, we want you to be aware that we need to increase the fan speed higher because our cabin pressure is lower. We're trying to get that cleaned up this afternoon, but we're not quite there yet. So more on that later. We also have a crew procedure that we will need you to execute, and it is the suit DOF vehicle config procedure, which is 22.2.102. This is steps 1 through 7 to get the vehicle back in a good config following being suited. We need you to stop the HHP camera feed, please. We do not see it, but we need to stop it for bandwidth reasons. We want to tell Reid that his PCD-1 is go for email use. We also can tell you that we have good targets on board for OTC-3. It's looking like a 10.1 foot per second burn. And then finally, your flight director will be ready to speak with you for Reid's flight director conference coming up shortly.
Okay, Jenny, copy the fan speed thing, but no action for us on that. Suit DOF vehicle config, steps 1 through 7. We will stop the HHP camera stream. Reid is go for, actually that's complete. Reid is go for email on his PCD-1, and we'll be ready to talk to Jeff. We understand we will be suit drying per the suit DOF procedure as well. Please confirm.
Affirm, that is a good readback on all, and we agree on the suit procedure. Thank you, Christina.
Can you still hear me okay? Great.
This is Artemis Mission Control here with an MET 4 days, 1 hour and 24 minutes into the Artemis II flight. The crew has wrapped up their Ox suit demo, that was the Orion Crew Survival System suit demonstration, and are moving into their midday meal time frame. Later today, we'll have the OTC 3 burn, that's the Outbound Trajectory Correction 3 burn. This is scheduled for 10:03 p.m. Central Time, and we are now expecting this to be a 10.1 foot per second burn. I'm joined today by Ox project lead, Dustin Gomert. Dustin, thanks for joining me.
Oh, thank you for having me.
So this is, tell me about your role.
Well, I'm the Ox project manager, system manager, whatever role you need me to be, but I kind of have them all. And so our team is in charge of the Ox, the Orion Crew Survival System suits that are on Artemis II right now.
And we saw a test of those today. So can you tell me about those Orion Crew Survival System suits, Ox suits? We have called them both things all day long. Can you tell me about those and what makes them unique?
Well, the thing that makes them different than anything we've done before is their long duration survival capability. And so these suits are very specifically designed such that if something were to happen to the crew en route to the moon or while in lunar orbit, they could survive in them for up to 6 days. And so it's a pretty unique capability to have that where your environment, your home, your personal atmosphere is just bigger than your body, and they still provide the functions for you to keep being human and doing all the things you need as a human while in this environment.
And today was not the first time that this crew has suited up. Obviously, they wore these on launch day, but what other kind of tests were run here on the ground in these suits, either with or without the crew?
Quite a few. So we spent a good I would say almost 2 years doing certification testing of this, and the better part of a decade in design and tweaks of them to get to the point we are today. And the crew, have spent almost 2 years training in the suits. They get custom fit for each one. Every person is measured, every joint of their body down to even individual finger segments almost are measured for the crew. And so we have them very finely tuned and finely trained for activities that they would do in these suits. The thing we can't do in these suits on the ground is truly understand how they behave in microgravity. And that was one of the things we were after here today.
Yeah, what about microgravity makes it easier or more difficult in some ways to test these suits, or even just being in the Orion capsule? Oh, 1 minute as we're hearing some comms from the crew.
From around an hour-long forward LOS. No response required.
And we are expecting a loss of signal with the Orion crew. And I'm so sorry to interrupt you, but as we were saying, being in the Orion cabin and being in microgravity can make things more or less difficult in these suits. So what are some of those fine difficulties?
Well, in all honesty, that was some of the things we were looking to learn today. The key difference from what we can test on the ground is that no matter what we do here, you have gravity biasing you. And so even if we were to go, say, to the neutral buoyancy lab and weigh out the suit so it was effectively weightless, the body inside is still weighing down with gravity. And so that will naturally shift you in one direction or the other inside the suit. Maybe your head goes up or head goes down, or you go forward or you go back. On ground, we test them in every possible axis. We turn them on their belly, on their back, on their side, and we try to get every possible fitment. At the end of the day, you still don't fully know. And so this test, one of the things we're looking to get out of it is how do you truly fit inside that suit as we predicted in microgravity to give us that confirmation. You know, do your elbow joints still align? Does your wrist joint still align? Does your head still fit in the right position that allows you to do all the motions that they've been trained to do? And so we're looking forward to following up with the crew after this test to learn a little bit about what they experienced and take those notes and help refine it for the next missions.
Well, it was very interesting to see them in the cabin, suited up today, and of course we'll see this again for Splashdown Day. So thank you so much for joining us, Dustin. We really appreciate it.
Oh, thank you. It's a pleasure to be here.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. You're looking at a visualization of Orion and its current configuration as it flies toward the moon. We are now just 48,722 miles away from the moon and 226,700 miles away from Earth. You can track Artemis and track Orion for yourself at any time by visiting nasa.gov/trackartemis. Tomorrow is a big day for the mission as we will have the lunar flyby with about 6 hours for the crew to be taking photos, making observations and annotations of what they see as they pass the moon. The first humans to do so in over 50 years. Of course, we'll be live for it all, so we look forward to you joining us. One of those milestones that we'll see is them surpassing the greatest distance ever achieved by humans. That was set by the Apollo 13 crew. We expect that to occur in 17 hours and 38 minutes, so don't miss it. We are currently in a forward link LOS, or loss of signal, with the crew. These are tracked as we fly this mission. We are using the Deep Space Network at this time. They are far enough away from the Earth that we need to rely on this network rather than our usual tracking data relay satellite systems that you see us use with the International Space Station. But we are aware and track all of these moments when we are loss of signal with the crew. However, we still have data from them. So if they needed to, they could call down to us here in Mission Control. And we expect to get that forward link acquisition of signal back in about 37 minutes. The crew is currently in their midday meal. They previously executed the Orion Crew Survival System demonstration. This involved all crew members getting in those orange suits you saw them in during the launch. This is also what they'll wear during their return to Earth. Those suits could help them survive a depressurization event in the event that were to occur on the spacecraft. Of course, today was just a test, but that would give them a breathing environment for about 6 days. At 10:03 p.m. Central Time, we are expecting the outbound trajectory correction burn 3. We did cancel the first of these 2 trajectory correction burns. These are small maneuvers using the reaction control system thrusters on the spacecraft that help us fine-tune our trajectory around the moon and on our way back home to Earth. The team will execute the OTC-3 burn tonight. We expect that to be a 10.1 foot per second burn. This is Artemis Mission Control here at Johnson Space Center in Houston, Texas. MET, 4 days, 1 hour and 52 minutes into the flight of Artemis II. Correction, we are 4 days, 2 hours, and 14 minutes into the flight of Artemis II. We are in a forward link LOS, meaning we are out of communication with the crew from the ground side. These are tracked, and the team monitors them and make sure to call up anything to the crew just before we go into them and let them know that we won't be able to communicate with them for this time period. We expect to regain communications with them in under 10 minutes.
Integrity Houston after the LOS. How do you hear? Integrity, we have you the same. Please execute procedure 2.1.0, cabin leak suspected. We need to get the cabin pressure control to maintenance. This will perform a cabin O2 introduction. Good words. No, it does not. Cabin pressure is stable, but we need you to perform this procedure to get cabin pressure control to maintenance. Copy. We're here for whatever you need.
We don't read it that way.
Let's perform step 3 of this procedure, cabin leak suspected. Step 3. Good words. Affirm. Copy. That's a good config. Thank you, Reid. All right, Integrity crew, I am now ready to pass you big picture words on what happened.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. We have reestablished communications with the crew. We did go into an LOS on our forward link. That was a planned and tracked LOS. And then we also experienced an LOS on the return link, the link where the crew is able to communicate with us. We have since done a string swap, sent that up, and we have communication with the crew that we're working to get back into the broadcast. The crew also received a cabin leak.
Into the LOS is that when you went to RADHAB in the suit drying procedure, we went to a suit state with a lower cabin fan speed. This caused a little shift in the outlet pressure of the cabin fan where that pressure sensor is, and it registered a pressure change. So we got that warning, cabin leak suspected, in alarm. This moded the cabin pressure mode to idle, which meant that we stopped O2 introduction into the cabin. We needed to mode back to maintenance to regain O2 introduction back into the cabin. Copy. And I see what you see about the procedure. We just wanted to make sure we called you into that. Step 3 was the important part there. Second of all, we had an unexpected return link LOS when we transitioned to DSN Madrid. We had good luck, but we weren't getting any data. When we got forward link, in our INCO sent a command for a string swap, which was successful. We are now on string 1 for S-band. Okay, and we are still looking at what happened with S-band string 2. We don't know yet, and that's all I have for you. Thanks, guys. Sounds great. Thank you, Reid.
Again, we are working on getting the crew audio back into the broadcast, but you heard Capcom Jenny Gibbons, CSA astronaut and Artemis II backup, communicating with the crew some of our recent changes on the spacecraft. As we went into the LOS with the crew, that loss of signal, which we were expecting, we also noticed a cabin fan change, which caused a cabin leak suspect warning. There was no cabin leak. We needed to mode back to a maintenance option and reintroduce oxygen into the cabin. You also heard Gibbons explain that when we transitioned on the Deep Space Network to the Madrid site, that we ended up losing the crew's communications as well, that we had a good lock on the spacecraft, but we just weren't receiving their data. Our INCO flight controller conducted a string swap to regain that data. We now have good data and communications back with the crew. You'll also be noticing more people filtering into the flight control room. The Orbit 1 team is handing over to the Orbit 2 team. On your screen, you can see Capcom Jenny Gibbons handing over the console to Mark Reagan. That's the voice you'll hear throughout the Orbit 2 shift with the crew. One of the major milestones coming up for tonight will be the OTC-3 burn. That's Outbound Trajectory Correction 3. We execute these small burns using the reaction control system thrusters on the spacecraft to help us refine our trajectory as we begin to fly around the moon tomorrow and come home. A splashdown in the Pacific on flight day 10. While we were in that LOS with the crew, they were in their midday meal, and some of the options they had today include chicken noodle soup, chicken with peanut sauce, spicy green beans, mashed potatoes, roasted turkey, rice, tomatoes and artichokes, spaghetti with meat sauce, vegetable casserole, sweet and savory kale, shrimp curry with rice, and a personal favorite, macaroni and cheese. I cannot omit that there was also a cosmic brownie as a dessert option.
Integrity Houston, no action on the enabled prop cautions on the board.
Integrity copies. Thanks.
Integrity Houston, for the enabled caution, these prop cautions are because we are manually pressurizing that branch for upcoming OTC3. We're taking a closer look at them. No action for you.
Integrity copies. Thanks.
This is Artemis Mission Control at Johnson Space Center in Houston, Texas. We are now 4 days, 2 hours, and 51 minutes into the flight of Artemis II. Our crew today woke up at 11:05 a.m. Central Time. They stepped into their post-sleep period, and notably, Canadian Space Agency astronaut Jeremy Hansen received his gold astronaut pin, meaning he is now a flown astronaut. The first half of the crew's day has been spent in the Ox Suit demo. That stands for Orion Crew Survival System Suit. During that time, the crew all got into their orange suits that you saw during launch day and that they will wear again on the return day. The crew can ingress these suits if there were to be a depressurization event in the spacecraft. Obviously, that is not what we were expecting or doing today. This was only a test for the crew to see how it would be to put on their spacesuits in that sort of environment. 2 of the crew were instructed to get into their suits rapidly. The other 2 crew members were instructed to get into their suits at a regular pace. After that, we had 2 of our crew members ingress or get into their seats as if they were preparing for return. We also pressurized the suits. Again, this is a flight test, and every day is an opportunity to test a different system aboard the spacecraft. Coming up this evening, we have the OTC-3 burn. That is the outbound trajectory 3 burn, and we'll continue to refine our path around the moon and back home. Orion is now 46,395 miles away from the moon, 228,329 miles away from Earth. That number continuing to increase while our distance from the moon continues to decrease, scheduling with our lunar flyby scheduled for tomorrow. With Orbit 1 handover here in Mission Control, being handed over to the Orbit 2 team, that'll also do it for us, or for me, here in Mission Control Houston. I will be handing over the Public Affairs console to my friend and colleague Anna Schneider. We will continue our 24/7 coverage on NASA's YouTube all the way until the crew is splashed down and safely recovered. So don't go anywhere. Anna will be joining you shortly.
Integrity on 1 for lunar viewing.
Go ahead, Reid, for lunar view. And for your info, you came down on 2.
All right, Jenny. The moon is decidedly large out the window today. We can see all of Apollo, all of Oriental, annular ring. We can see, I'm 99% sure, Ohm, see Pirazo very easily, and just getting over. Can't quite pick up Vavilov yet, but that far side that is right on the limb is extremely mountainous. Try to get some pictures, but it's a high grazing angle. But it's pretty awesome to just look out and see all of these sites, and it's bright, but very visible with the naked eye. Still primarily seeing whites, grays. Maybe I can convince myself on the far side there's some just hues of brown, very light, very, very faint. But it's a great view. It's beautiful. And on the near side, Aristarchus is by far the most prominent feature. It is really just glowing bright right now.
That's beautiful, Reid. Thanks for bringing us all up there with you.
And for the science team, Pirazo and Aristarchus have the same albedo level right now. They're the same level of brightness. And then looking down, Copernicus is just a little bit dimmer, but it's close.
Science is loving it, as expected. Thanks, Reid. While I'm talking to you guys, I have a topic on burn monitor for Jeremy.
He'll call you back in about 5 minutes.
Sounds good, no rush.
Houston Integrity, just one other observation. Looking at the Terminator, it's almost a full moon from this perspective, but we got the Terminator on the western edge of the moon, about 1 Oriental diameter from Oriental, and just with our plain eyes, you can really start to see topography. There is elevation on the moon, not just variation in color, and that already makes the moon look wildly different.
You have a lot of people looking forward to tomorrow. Thank you so much.
This is Artemis Mission Control in Houston, Texas. The Orbit 2 team of flight controllers has recently come on console, and they are being led by Flight Director Diane Daly. And they have handed over from the Orbit 1 team of flight controllers, and we just heard some communication down from the crew, specifically NASA astronaut Reid Wiseman and Victor Glover, as they were making some observations of the moon as they continued to close in on their distance between the Orion spacecraft and the moon. Currently, they are about 45,000 miles from the moon, again, making some observations about the basins and craters that they are seeing as they continue to close that distance with, of course, the lunar flyby and closest approach planned for flight day 6, which will be tomorrow, Monday, April 6th. Coming up here in about
Hansen Integrity for Photo TV.
Go ahead.
Just an observation with the D5. Through the optical viewfinder at 400 mils, the moon is crisp, absolutely clear, even with a high grazing angle through the windows. But when we are taking pictures, what we then see in the viewfinder is a bit blurrier than what we can see through the viewfinder. I just find that odd. I would have thought the viewfinder and the sensor would pick up the same data, but you can pass that along to those folks.
All right, we got it. Thanks for the call down.
This is Artemis Mission Control. Coming up in just under an hour and 20 minutes from now, the outbound trajectory correction 3 burn will be executed. This burn is expected to be about 18 seconds, and it will use Orion's orbital maneuvering system engine, or OMS engine, to ensure the spacecraft stays on target for its journey around the moon. There were 2 previous outbound trajectory correction burns earlier during the mission that were canceled, as it was determined that those burns were not needed, but they will be executing this outbound trajectory 3 burn coming up here shortly.
we're ready for those burn monitor words.
Hey, Jeremy. Good afternoon. The first thing is that step 10 is complete. The plus X flange heaters are on and prop avionics are configured. And then also, assuming that RHC is not currently deployed, that setup was back on step 7. If you want to refer to that, the bingo for that is TIG minus 45.
Okay, RHC is deployed, and we copy the prop step is complete. Appreciate it.
You are welcome. And just a couple of other general awareness things. We are working on updates for the day, and we will be getting that up to you shortly. We also have the lunar targeting package verification steps in message 3.05.05. That should take about 5 minutes to run on each of the PCDs, but we do need to wedge that in somewhere today so that if it doesn't work, we have a little bit of time to troubleshoot before tomorrow.
Okay, I can work on that actually. So I see it here. It's on this PCD 3.05.05.
Yeah, that's great, Jeremy. And we'd like to get confirmation that run through that procedure and get confirmation that all of the remaining working PCDs are functioning with this.
Okay, that would put us at ease as well. So we'll let you know on that shortly. For the burn pad, we noticed that that the delta V had changed quite a bit. So when did you want to get with us on the burn pad?
We're just planning to do that at the final burn conference, Jeremy.
Okay, that's fine. Just confirm the latest version that we're going to be referencing in that burn conference is UTC of ground generation 95/1400 hours.
Yes, Jeremy, that's correct. And just for context, the manual piloting is what changed that a little bit, the total delta V.
Well, we'll take that as a compliment.
Wouldn't have meant it any other way.
This is Artemis Mission Control in Houston, Texas. You're currently seeing a live view inside Mission Control here. We were hearing some communication up to the crew, and the individual responsible for communicating directly with the crew is the Capcom or capsule communicator, who is on the left-hand side of your screen.
We're setting up some charging for tomorrow. the alternate PCD charging cable. Do you guys have the bandwidth to look that location up for us?
We do. Stand by. Looking for it now.
The Capcom currently on console as part of the Orbit 2 team is Mark Reagan, and you can see him there in the bottom left-hand corner of your screen, and he is sitting next to the Orbit 2 flight director, who is in the upper right-hand corner of your screen. The flight director on console is Diane Daly. The crew has been discussing a few different activities that they're working through. One of those is verifying that they have the final lunar targeting package available on their PCDs, or portable computing devices, which are basically tablets, that they're able to reference the various procedures and timelines that they're following throughout their mission. They were also discussing an upcoming burn conference, so they will have a conference directly with the flight director and the flight control team here in Mission Control Houston ahead of that outbound trajectory correction burn. That final burn conference is scheduled to take place in about 20 minutes from now.
Integrity Houston for the alt PCD power cable.
Go ahead, Mark.
Yeah, Jeremy, you can find that in E-Locker, bag number 10 with a brown label. And the Ziploc bag is called 15-volt PCD power cable.
Okay, copy that. Thank you, Mark.
Yep, you bet.
Houston Integrity for timeline.
Go ahead.
Hey, Mark. Question about an activity, depressed acoustic monitoring on my timeline at 02 today. I believe since we had aborted the acoustic monitoring the 24-hour yesterday, I didn't see an activity to start this acoustic monitoring.
Hey, Christina, that's going to be a no perform today. And I am on the verge of giving you some other timeline deltas here.
Copy both. Thank you.
Integrity Houston with some timeline deltas.
Okay, go ahead, your timeline deltas, Mark.
Okay, well, first of all, this just in, the SM prop helium ISO valves are configured, which is in step 12. And then for the timeline deltas, the things that we must perform today are that LTP verification we just talked about a few minutes ago, OTC3 burn ops, the toilet maintenance, the post-oxsuit DFTO cabin inspect, AGA readings, and the PMC. How copy on that?
Okay, we copy all that. A couple notes from us. 2 out of 3 of the PCDs for LTP are complete and they're correct. I'll work on the third one next. We talked as a crew and we would like to defer today's PMC. We just don't need it.
Okay, copy that. All right, then a list of suggestions that can be deferred if you would like to.
Sorry, say again, Mark.
Yeah, let me say it more eloquently than I was about to. Everything else can be deferred as you guys desire.
Okay, appreciate it. That's great.
And Jeremy, sorry, one late add to the must be performed. We also need to repower that docking cam today. And then as bandwidth permits, we would love...
Understood. That makes sense.
All right, cool. As bandwidth permits, we would also like to understand your cabin config too, but as bandwidth permits.
Yeah, we can set up a little tour for you. I think you're going to be really impressed. I mean, we've done a great job here. Looks good up here. It is better than before.
Awesome.
This is Artemis Mission Control in Houston, Texas. Again, we were hearing some communication between the crew on board the Orion spacecraft, which is named Integrity, and the team here at Mission Control. They were discussing some of the upcoming activities on the timeline for the remainder of the crew's day. Earlier today, following crew wake up, the crew jumped into a AUX suit, developmental flight test objective. AUX is the Orion crew survival system suit, that orange suit you see them wear for dynamic activities, including launch. They donned their suits or put them on and performed several different activities wearing those suits, but they were running behind on the timeline a little bit, so they are working to free up some of the remaining activities and defer activities that aren't critical to take place today. So that is what a majority of that conversation was about. So following the outbound trajectory correction burn, which is scheduled to take place in about 51 minutes from now, again, it's a very small correction to fine-tune the trajectory of the Orion spacecraft as it makes its final approach and goes around the moon and returns back to Earth. Again, that lunar flyby planned for flight day 6 on Monday, April 6th, and that splashdown will be on Friday, April 10th. Following that burn, they will just have a few remaining activities to be completed for the day, including some standard anomaly gas or AGA readings that they take to measure the gases such as carbon dioxide in the crew cabin. They also have some toilet maintenance activities that they complete every day, and then they will have a post-aux suit developmental flight test objective cabin inspection that they will complete before they head into their pre-sleep period to wrap up flight day 5.
Integrity Houston, we're about 3 minutes away from the starfield maneuvers.
Okay, we copy that, Mark, and I've got something for you on lunar targeting package when you're ready.
We're ready.
So PCDs 1 and 2, everything worked perfectly. PCD 3, the lunar targeting package when I double click on it, it tries to open, goes to the web page, and then the little in process circle just keeps going and going. I waited quite a while and it never opened. So then I started the troubleshooting where I created the shortcut and renamed it on the desktop, but I get the same signature when I try to open it, and it's just chewing away with the little satellite going around the moon.
Okay, Jeremy, copy. We're chewing on that. We'll get back to you with more words.
Okay, thanks.
This is Artemis Mission Control. We just heard some communication there between CSA or Canadian Space Agency astronaut Jeremy Hansen, currently on board the Orion spacecraft as it makes its way towards the moon. He is working to verify that the final lunar targeting package, which they are referring to as the LTP, is available and uploaded to each of the crew's PCDs or portable computing devices, basically a tablet that the crew is able to use and reference various procedures during their mission. That lunar targeting package will be the primary tool guiding crew observations during the lunar flyby on flight day 6, which will take place tomorrow on Monday, April 6th. It consists of two key components, the lunar geography review and the lunar targeting plan. The lunar geography review helps astronauts study major lunar features in advance of the flyby and learn how to orient themselves during the flyby, while the lunar targeting plan provides a detailed timeline of observation targets, background science context, and specific instructions for imaging and making verbal descriptions.
Integrity Houston, you ready for the burn conference, Jeremy?
One minute, please.
Raj.
Houston, Integrity is ready for the burn conference.
All right. As we discussed earlier, the UTC of ground generation was 95.14 even. And the first delta is delta V total.
Check.
Which is 10.4. TGO is 19 seconds. Attitude should be yaw pitch roll 312, 315, 75. And delta V XYZ should be 4.7, minus 5.3, 7.6. How copy so far?
We copy all.
Okay. No deltas in the burn execution steps. And then finally, in the burn notes, one delta, which is that we have already manually pressurized the fuel tank to 290 psia, and pressurization will still be active during the burn config segment. The burn will be performed in blowdown.
Copy.
Any questions for us?
Mark, to be sure we understand your last, we understand you said it is pressurized now and that we will be in blowdown. Is that a good read?
Yes, that's a good read back.
Hey, Mark, in your first statement, we thought we heard you say it would be pressurized during the burn, which doesn't match our understanding of blowdown, but maybe we either misheard or you said like it would be pressurized now but not during the burn.
We did pressurize it a couple of hours before TIG, and it will still be active.
Mark, we're scratching our heads a little bit on what you mean about it will still be active and marrying that up with being in blowdown. Our understanding of blowdown is that we would not have active pressurization, but we would use the existing pressurization.
Okay, sorry, yeah, I've made it more confusing than it had to be. That's a good understanding. The pressurization will still be active during burn config segment, and the burn will be performed in blowdown. Does that make more sense?
Thanks, Mark. That makes a lot more sense. So at some point during burn config segment through the start of the burn, the active pressurization will be turned off.
Yes, that'll happen when we transition at TIG minus 5 minutes.
Perfect. All understood on board. Thanks for going through that with us.
Of course. I also have some troubleshooting steps on that LTP that wasn't working properly on PCD3 when it's a good time for somebody.
Yeah, you can go ahead and send that now, Mark.
Okay. You can pull up procedure 36.1.3, which is Lunar Targeting Package User Guide. And you can execute step 6.1.2, which clears the cache, and then go back and try that message 3.05.05 again.
Okay, just give me the procedure. I got it was step 6.1.2, but say again the procedure number.
It's 36.1.3, Lunar Targeting Package User Guide.
Okay, I'll put that in work.
All right, thank you. Integrity Houston, confirm TLT and orb guide converged. we're assessing the onboard solution.
They did converge, and we are assessing versus the burn pad now. So far, so good.
Copy.
Houston Integrity confirming your go, no-go for this burn.
We are about to put that in work. Stand by. Integrity Houston, MCC has pulled go for the burn.
Integrity copies.
This is Artemis Mission Control in Houston, Texas. We just heard confirmation there that the team here in Mission Control has pulled go for the upcoming outbound trajectory correction burn 3. This burn expected to take place in about 26 minutes from now, and it will be an approximately 19-second burn using the auxiliary engines on the Orion spacecraft. There were previously 2 other outbound trajectory correction burns on flight days 3 and 4 that ended up being canceled as it was determined they were no longer needed due to the accuracy of the translunar injection burn on flight day 2. However, the team decided to go ahead and execute this outbound trajectory correction burn 3 today on flight day 5 to ensure an accurate trajectory as the spacecraft begins to make its way around the moon and back to Earth to minimize further larger trajectory corrections that may be needed on the return journey.
Orion Integrity for the LTP.
Go ahead, Jeremy.
Okay, I cleared the cache as per the procedure. Then I tried to open the original LTP link, and I got the same signature as before, so I cleared the cache again, and then I opened the new LTP link that I created myself, and I get the same signature.
Okay, back to head scratching here. Integrity Houston, tank pressures are good for the burn.
Integrity.
Integrity Houston, our email sync is complete. All inboxes are unlocked. Integrity Houston, solar arrays are in position for the burn.
Integrity.
This is Artemis Mission Control. We've heard a couple of call-ups from the ground here in Mission Control ahead of the upcoming outbound trajectory correction 3 burn, which is planned for about 16 minutes from now. One of the first call-outs was in regards to the propellant tank pressurization, confirming that service module tank pressure is in the proper condition for the upcoming burn, and then also confirming that the solar array wings on the Orion spacecraft are in the correct orientation to support the upcoming burn. Again, this burn is expected to last about 19 seconds using the auxiliary pulse-X engines on the Orion spacecraft service module. The flight control position here in Mission Control Houston, responsible for the solar array wing specifically, and that most recent call out is MPO, which is the mechanical and power officer. They are responsible for the electrical power generation, the solar arrays, the array rotation mechanisms, and power distribution systems on board the Orion spacecraft.
Integrity Houston, maneuver to burn attitude starting in about 3 minutes.
Integrity.
Integrity Houston, we're in burn attitude.
We see the same.
This is Artemis Mission Control in Houston, Texas. We just heard that confirmation called up to the crew on board the Orion spacecraft that the spacecraft has maneuvered to the correct burn attitude in preparation for the upcoming outbound trajectory correction 3 burn scheduled to take place in about 5 minutes from now. This is Artemis Mission Control in Houston, Texas. You're now seeing a live view of the Orion spacecraft, the exterior of the spacecraft, as we are about 2 minutes out from the upcoming outbound trajectory correction 3 burn. That burn is expected to last about 19 seconds, taking place around 10:03 p.m. Central, 11:03 p.m. Eastern Time. This burn will fine-tune the trajectory of the Orion spacecraft to ensure it stays on target for its journey around the moon and back. This is Artemis Mission Control. We are about 30 seconds away from the time of ignition for the outbound trajectory correction burn. That is when the auxiliary thrusters on the Orion spacecraft service module will begin firing to complete the outbound trajectory correction burn and fine-tune its trajectory. And we have confirmation that that outbound trajectory correction burn is now underway. And we now have confirmation that that burn has completed. Again, that was an approximately 19-second burn using the auxiliary thrusters on the Orion spacecraft service module. That burn completed at 10:03 p.m. Central Time, 11:03 p.m. Eastern Time to further fine-tune the Orion spacecraft's trajectory as it continues to make its way around the moon, and it was a good burn.
Integrity Houston, good burn. We are assessing the details.
Good news, and we see the same. Thanks, Mark. Houston Integrity, pending your analysis, we would like to ask you to take over on step 23. We'll handle the RHC and get on with some other activities on our timeline.
All right, you got it.
Thank you. Great to finally do a burn.
I know. It's a nice, beautiful little burn, too. Hey, be advised we are maneuvering for opportunistic science, and you would need to configure your D5 and Z9 cameras for that, like yesterday.
We are tracking and looking forward to it very much. We had a gorgeous view of a very big moon right out of window 2 during that burn. Well, right before the burn, before we maneuvered. It was awesome.
And looks like we'll be back at window 2 for this as well. And also I have another little troubleshooting step for that.
Thanks for that heads up.
Yeah, you're welcome. Another troubleshooting step for that lunar targeting package when someone has a chance to copy.
Okay, send me the troubleshooting steps there, Mark.
Okay, Jeremy. Back to that same step, 6.1.2. Do you still have that procedure that was in?
I do. It's just clearing the cache, and I understand understand it now?
Yeah. This time we're going to, on media 14, which is the one at the bottom of that step, we are going to change that time range to for all time. And then in addition to the cached images and files that you see already checked in that procedure, we're going to check cookies and other data. And then clear it, and then back to message 30505 and try again.
Copy that. Just so you know, I did all time previously, but I didn't do the cookies and other data, so that's new. So I'll try that. Well, I just did it, and I'll see what happens. And then which LTP do you want me to try to open first? The one that was already there originally, or do you want the one that I created the new shortcut for on the desktop?
Checking. Jeremy, try the original shortcut first.
Didn't work. Hooray! That fixed it.
All right.
Okay, Mark, and I did the other two steps too, checking the two one-note actions, and they're both good on this PCB now, so we're all set.
That is awesome. Thanks, Jeremy.
This is Artemis Mission Control. About 7 minutes ago, the Orion spacecraft executed the outbound trajectory correction 3 burn to fine-tune the trajectory of the Orion spacecraft as it continues to make its way around the moon, with that lunar flyby planned for tomorrow on flight day 6. Now that that outbound trajectory correction burn is complete, teams will be maneuvering the Orion spacecraft into an attitude to be able to capture some opportunistic imaging of the moon.
Houston Integrity for enabled flush caution.
Yeah, go ahead.
We just got an enabled caution dump required.
All right, we see that as well, and we are about to put a wastewater dump in place and get that going shortly.
Okay, sounds good. And do you have the bandwidth for an HHP quick cabin view of the egress wall for the post DFTO cleanup?
We are checking, and just to make sure we're on the same page, so after this use, stand down from toilet ops until we get that dump done and let you know.
Understood.
Yes, we can take the HHP cam.
And hey, Mark, just to be 100% certain, secondary dumps are still okay, correct?
Yes, secondary dumps are still okay. Integrity Houston for toilet maintenance.
Go ahead.
Yeah, some good news. Since we've had pretty low usage on the toilet, the oxone change out is not required, so those steps can be skipped in that today.
Mark, we appreciate it, but that is already done.
Okay, copy. We'll schedule accordingly.
This is Artemis Mission Control in Houston, Texas. We are currently 4 days, 4 hours, and 53 minutes into the Artemis II mission, following a liftoff from NASA's Kennedy Space Center in Florida on April 1st at 5:35 p.m. Central, 6:35 p.m. Eastern Time. On your screen, on the left-hand side, you can see a view of the Artemis Real-Time Orbit website, which provides real-time data and telemetry updates from the Orion spacecraft, especially when we don't have live views coming from the cameras on the spacecraft itself. And in the bottom right-hand corner, you can see a view of
Integrity Houston, we show ourselves an attitude for the opportunistic science, and we'll be there for about the next 15 minutes.
This is Artemis Mission Control. A few moments ago, you heard a call up to the crew, noting that the Orion spacecraft is in attitude.
Confirm you got a good HHP stream.
We are working it now. So not yet.
Spacecraft is in attitude for the crew to be able to capture some opportunistic science imagery of the moon, looking out of some of the cabin windows of the Orion spacecraft. They were referring to an HHP camera, that's a human health and performance camera inside the Orion spacecraft camera or cabin that they are working to turn on, and we should be getting those views here shortly of the crew inside the Orion spacecraft.
Okay, Reid, finally that cleared up, and now we have a good image inside the cabin.
Okay, we have too many views out the windows right now. We got the moon out 1 through 4, and then Jeremy just spotted Earth out the side hatch window, so we're going to work on all that. But I just wanted to give you a quick once-over. Nobody ever sees the cabin from this side except for us. So I got the camera over on the side hatch side. You can see the Equus wall there.
This is Artemis Mission Control.
Yeah, that's good, Reid. We're seeing that real well.
You're now seeing a live look inside the Orion spacecraft as the crew completes some opportunistic imaging of the moon. It's a bit dark inside the spacecraft because they've turned off the interior lights to provide a better environment to capture some of those images.
Mark, if there's anything of interest you guys are looking for, I'll highlight it. Right now, I'm highlighting a part of Jeremy that probably doesn't need to be highlighted.
Roger that. Could we ask for a slow pan of the port wall, the lap and the food warmer area? Haven't really seen much of that yet. And this is just for curiosity. We're not concerned about anything.
Christina did take some cabin config photos. There's the PWD area.
We're not.
There's the food warmer galley area. Maybe you can see the bungee jail there. I don't know if it's too dark or not.
Yeah, that's a good view. We see those IT cables just wishing they could grow like they did on Space Station.
I just spent about 45 minutes tucking all that stuff down and running power cables for the lunar flyby tomorrow, so it looks a lot better than it did 2 hours ago.
Oh, that's awesome.
All right, Mark, with that, I'm going to stop the feed, and I'm going to go look at the moon for a minute.
All right, copy that. Thank you. We appreciate that extra time. and Integrity prop post-burn reconfig is complete.
Integrity copies.
This is Artemis Mission Control. The crew is currently completing some opportunistic lunar science imagery where the Orion spacecraft was maneuvered into an attitude in order to be able to complete that imagery. And there on your screen, you are seeing a live look outside of the Orion spacecraft. This is coming to you from one of the solar array wing cameras. And in the bottom portion of that view, below one of those solar array wings, you can actually see the moon there. Later today, the Orion spacecraft and its crew will reach another important milestone when it enters the lunar sphere of influence, which is when the gravitational forces of the moon will be stronger than that of Earth.
Houston Integrity for the opportunistic science. The images are complete. The view that we have now, the most striking things are the size of the moon and the detail that we can see with the naked eye. It is almost a full moon, maybe about 10% on the western limb is in the terminator, and you can really see variations in terrain. There's clearly some large elevation changes on the western edge that's at the terminator area. The view that we have now at the center is Grimaldi. It's almost dead center. It's just slightly south of center. And Orion Tall is not quite an orthogonal view, but we're able to really see into it, and you're starting to be able to differentiate the colors that are not the differences in the gray that are down in there. Like there's a dark gray V on the bottom, and then a light gray V on the top in the center of Orion Tall. And the lighter gray actually matches the rings that are out to the northeast, and the dark gray V in the bottom matches the part of the ring that's very easily visible in the southwest. Also, Grimaldi is the darkest that I can see so far, and then there's one spot that's just to the northwest of Grimaldi that is also very dark, but it really makes Procellarum and Oceanus look lighter. The grays there almost look like looking down on a forest where you can kind of see variations, splotches between light and dark gray. It doesn't look as consistently dark as it does from so far away. And the variation and all that mare. There's a lot of detail in the variation in the dark grays in that mare, and it really stands out now because Aristarchus is so bright in the center of all of that. But again, the biggest things that stand out to me are the size of the moon out the window to the naked eye and the terrain that I can see on the western limb due to the Terminator. I love the Terminator.
That's awesome, Victor. Really good description. It's easy to imagine what you're looking at. Thank you for that. Integrity Houston, heads up, 2-minute warning till we maneuver back.
This is Artemis Mission Control. We just heard some communication there between NASA astronaut Victor Glover, who is the pilot on board the Orion spacecraft, as the crew is completing some opportunistic science imagery of the moon, and they were providing some of that science description down to the team here in Mission Control Houston. The crew has about a 15-minute block to be able to complete this opportunistic imaging, so they're towards the tail end of that block, and then the Orion spacecraft, which you can see a live view of it on your screen, will maneuver back into a biased tail-to-sun attitude. This attitude allows the spacecraft to manage thermal constraints and power generation, and it's the primary passive or passive safe flight orientation during transit. And there you can see that attitude maneuver now taking place to move back into that biased tail descent attitude with the moon in the lower corner of the screen.
I'm not asking you to break any analysis, but if you could give us 3 more minutes in this attitude, we would take it. We're just trying to wrap up some images, but we understand if you can't. And disregard, we see we're in the maneuver, never mind.
Yeah, sorry about that. Could we make it up to you by getting you a little closer for tomorrow? Hey, while I have you, the darkness report of Grimaldi was unexpected and was something that has got the scientists excited to hear. So thank you for that one, especially.
You are welcome.
And this is Artemis Mission Control with that opportunistic science imaging block now complete. The Orion spacecraft, which you can see a live view on the left-hand side of your screen, is now maneuvering back to its tail descent attitude, or the passive safe attitude, which it typically maintains on its transit to manage thermal and power generation constraints. And then on the right-hand side of your screen, you see a view of the Artemis Real-Time Orbit website, or ARROW, which provides a visualization with live data and telemetry coming from the spacecraft. And so we are currently about 231,000 miles from the Earth, and the crew has about 41,000 miles separating them and the spacecraft from the moon. The crew on board the Orion spacecraft is expected to make their lunar close approach and their lunar flyby observation period tomorrow during flight day 6.
Mark, I think one of the most interesting things right now is the four of us have looked at this moon our entire lives, and the way we are responding to what we are seeing out the window is, it's just like we're a bunch of little kids up here. Just, we cannot get enough of this. It's amazing. Thank you for the privilege.
Thank you for sharing that special perspective you have with all of us back here.
This is Artemis Mission Control in Houston, Texas. You're currently seeing a live view of the exterior of the Orion spacecraft. These views coming to you from the solar array wing cameras. The Orion spacecraft has 4 solar array wings, sometimes referred to as SAW, and each of those solar arrays has its own camera. And this view you're seeing here provides a good look of the engines and thrusters that are on the service module of the Orion spacecraft. The crew is currently wrapping up their day. This is the 5th flight day of the Artemis II mission. They will be moving into a private crew conference with the flight director here in Mission Control Houston in about 5 minutes. Following that private conference, they will enter their pre-sleep period, and during this time, they will perform any hygiene activities that they need to before going to bed, and they will also eat their dinner for the day. Some of the items on the cruise menu for dinner this evening include cashew chicken curry, pickled beets, vegetable casserole, beef fajita strips, and fish with mango salsa. Ahead of any mission, the assigned crews typically work with the Space Food Systems Laboratory here in Houston, Texas, to taste the variety of space food options available and pick some of the items that they would like to eat during their mission. The crew often is able to pick some crew preference items. So, for example, CSA astronaut Jeremy Hansen has also brought some Canadian-specific items on board, including some maple syrup and maple cream cookies.
Integrity Houston, be advised that we're getting a little bit of Radicom. We've got structure in the way, and it's dropped out a couple of times momentarily or briefly. So if you don't get us at once, try again.
Copy that, Houston.
And this is Artemis Mission Control. You just heard some communication between the Capcom or capsule communicator here in Mission Control, which for the Orbit 2 ship currently on console is Mark Reagan, and the crew on board the Orion spacecraft discussing the current communication status between the ground and the spacecraft. The crew is about to enter into a private conference between them and the flight director to round out Flight Day 5. The crew typically has a private flight director conference at the end of each day, and the flight director currently on console for Orbit 2 is Diane Daly.
Integrity Houston for Reid.
Go ahead, Mark.
Yeah, I understand you temp stowed that snack bag that you prepared earlier today. You are go to double bag that and stow that with the rest of the snack stuff in A1. We're not going to use that, but we want it there because we're going to analyze all of that after you get back.
Maybe knowing that a few hours ago would help me not finish drinking that snack.
Or that. You could do it that way. Okay, and also...
if the team wants, I did get out 2 snacks earlier, and one of them I did not put any water in, and I re-stowed it. I can pull that one out and fill it, and then re-stow it just for analysis.
Not required. It's good in the config it is. And then also we have OE2 privatized for your conference, and you guys are welcome to meet Resolute Flight over there when you're ready.
Houston Integrity for wrap-up items.
Go ahead, Christina.
Hey, Mark, I have AGA readings when you're ready. Okay, when we turned on the AGA this time, we did have two alarms. One said for HCN, it was like a read error. I don't remember the exact verbiage. That was transient. It went away after just a couple seconds and then read off-scale low. Then we had the expected high oxygen alarm. Other values, CO2 3.1, oxygen 26.6, temperature 75, pressure 10.45.
Okay, we copy those. Do you have more stuff for us? Do you have?
And for the docking camera, we will be completing that activity shortly.
Okay, awesome. Is that it from you?
And Mark, we were just chatting that we probably owe you a report on Nat Geo shot list, and we have been referring to the shot list, and basically we really just have the cameras out almost at all times. We got the bird today, we got all the suit DFTO, and pretty much every day we've been catching day in the life items, whether that's mealtime or time at the windows observing, and any dynamic operations, and basically kind of the big moments of the day. So we do think we're capturing all those. Let us know if you need more granularity on that, but we are checking the list. We're making sure we get what they'd like and more.
Fantastic. Thank you.
That's all we had. Anything from y'all?
Yeah, just the one thing. We are about to start that wastewater dump momentarily, and I know it's pre-sleep time, but it will take any observations if you have them.
We're watching right now, and it's a light blizzard with kind of familiar larger particles and kind of pulsing, chugging. Not a ton of flow right now compared to maybe the higher flow primary dumps or the secondary dumps. But yeah, we're seeing something out there. We're seeing some kind of snowstorm.
Okay, copy. Thank you for the observation.
And Mark, it pretty much came to a complete stop there, and then there's been a couple little spurts, almost a complete stop right now while I'm talking to you.
Copy, Jeremy. We're going to keep it configured to dump and see how far we can get this down. Thank you for the insights. And if you do need to use the toilet, just give us a call.
Copy and understand. Thanks.
This is Artemis Mission Control in Houston, Texas. We heard some words from the crew on board the Orion spacecraft. Seeing a live view of that spacecraft on the left-hand side of your screen. Specifically calling down was NASA astronaut Christina Koch, who is one of the mission specialists for the Artemis II mission. They were providing some final updates for the remaining tasks on their timeline for Flight Day 5. They provided some AGA, or anomaly gas analyzer, readings. These readings are provided periodically to provide an update of any trace contaminants and also levels of things such as carbon dioxide in the cabin of the Orion spacecraft. They also provided an update on the docking camera installation. This is another task that is completed pretty regularly, especially ahead of the crew sleep period coming up. And then they also provided some updates on the imagery capture for activities related to a National Geographic documentary. And then
seeing flurries out the window now, and it's slightly increasing, just started.
Okay, that's good news. And Jeremy, we got one go back. If you could tell us where the images are from the day, we have good comm and to downlink that stuff right now.
Okay, you can look on PCD2 for the science photos that we took for the opportunistic science. And that's the only ones we've done so far. We're probably going to add a few more later.
Awesome. We'll go look there. Thank you. And if this is it, and I hope it is, good night to you guys. Sleep well.
Good night to you too. We had a great day.
And this is Artemis Mission Control. The final item that the crew was talking about just now was related to a wastewater dump. Again, this is a daily activity that takes place typically towards the end of the flight day. The Universal Waste Management System, or basically the space toilet on board the Orion spacecraft, typically vents its contents overboard each day. The crew is now heading into their pre-sleep period, and during this time they will have the opportunity to eat their dinner and also complete any remainder personal activities for the day to prepare for their upcoming sleep period. They typically have about 2.5 hours dedicated for that pre-sleep period, and then the sleep period itself will last about 8.5 hours.
Integrity Houston, no action for you. We're toggling right at that limit. We're going to inhibit that waste dump required message while we're doing this. Suppress that message.
Okay, makes sense to us. Thanks.
And this is Artemis Mission Control. There on your screen, you can see a live look of the Orion spacecraft as it's currently completing an attitude maneuver following that wastewater dump. These views coming to you from the solar array wing cameras. Again, there are four solar array wings, or SAWs, on the Orion spacecraft, which provide power generation. And each of those solar array wings has a camera mounted to it, and it provides some of these live views that you've been seeing throughout the mission.
Integrity on 1 for a 10.2 question.
Go ahead.
First on the dump, very slow flurries, and then the docking camera is powered. And then third, when we went down to 10.2, we just, obviously with the pressure change, a lot of our packaging up here expanded pretty heavily. And one that we noticed is the LIO bags, and we don't know if the LIO inside those bags is damaged by the pressure delta or not. Let us know if you would like to open up the Ziplocs there and take a look. I'm not sure if we have to go into the like the hermetic seal on that bag or not.
Okay, copy the question. We're talking about it. Hey, Reid, the LIO question. Nobody seems too concerned about that right now, but it is going to take a little while to talk to the MER and get a better answer than that. Would you like that called up tonight if we get that tonight, or would you rather just wait and hear it in the morning?
And Mark, we can wait. Thank you.
Okay, copy that.
This is Artemis Mission Control in Houston, Texas. We recently received confirmation that the Orion spacecraft and its crew have officially entered the lunar sphere of influence. That milestone taking place at a mission elapsed time of 4 days, 6 hours, 2 minutes, and 54 seconds into the Artemis II mission. By reaching this milestone, it means that the gravitational forces of the moon are now greater on the Orion spacecraft than that of Earth.
Now that the Orion spacecraft has entered the lunar sphere of influence, it will remain in this lunar sphere of influence through the lunar flyby. The lunar flyby is expected to take place on flight day 6, and currently the Orion spacecraft is about 39,000 miles away from the moon and about 232,000 miles away from the Earth.
Houston Integrity, there's now some photos on PCD3 in for downlink PAO flight day 5.
Copy that. Thank you.
Houston Integrity, PAO images.
Go ahead, Christina.
Hey, Mark, we have a few more images on PCD2 for PAO downlink.
Okay, copy that. In the meantime, we did get some answers back on the LIO question. The first thing, and none of this needs to be worked tonight, but just what the people are thinking is, first we would want to know if you can tell if the seals on the canisters themselves, the Kapton tape seals, are damaged or impacted. And then also we were looking for clarification on whether these were contingency or post-landing LIO.
Hey, Mark, the ones that we can see that are very poofy are post-landing. Our assumption was that potentially others that might be packaged the same are that way. But the Kapton tape of the canister itself, obviously we'd have to open the bubble wrap to see. So maybe that's something we can do tomorrow. But understand, no issue with opening the bubble wrap, which has Kapton tape over the Ziploc seal.
Right.
And one more clarification, the bag is opaque, so we aren't able to see through it to determine anything about what's inside.
Okay, we didn't understand that piece, but let's look at all of that tomorrow. In the meantime, if these things are so poofy that they're in your way and you just want to get them stowed, you have a go to vent them and make them their regular size.
Okay, I understand. So far, not too in the way, but we'll definitely address tomorrow as able around our awesome day of science. Thank you for the answers.
You bet. Thank you.
This is Artemis Mission Control in Houston, Texas. Currently on your screen on the left-hand side, you're seeing a live view of the Orion spacecraft. And on the right-hand side, you can see inside Mission Control here in Houston, specifically the CAPCOM, or Capsule Communicator Console, and the Flight Director Console. Currently supporting the Orion spacecraft and its crew and mission control are the Orbit 2 team of flight controllers, being led by Flight Director Diane Daly, and then the CAPCOM that you are hearing communicating up with the crew is Mark Reagan. The crew is currently in their pre-sleep period. They will remain in this pre-sleep period for about another hour and a half before they begin their sleep and round out flight day 5. Pre-sleep is typically a 2.5-hour block of time during which the crew has the opportunity to prepare for sleep by completing any hygiene activities and also eating their dinner for the day. On the menu for the crew's dinner this evening are a variety of items, but some of them include beef fajita strips, fish with mango salsa, creamed spinach, and chicken noodle soup. The food that the crew eats plays a key role in maintaining their health and ensuring they can perform their mission objectives to the best of their abilities. And long before launch, the teams here at the Johnson Space Center in Houston, Texas, began preparing so that the crew has had everything that they need to enjoy their around-the-moon meals. It started specifically with the Space Food Systems Laboratory, which supports the development and production of space food, menus, packaging, and food-related hardware for all NASA programs, including the Artemis program. And the crew also spent time practicing how to use equipment on board the Orion spacecraft to rehydrate and warm their food inside the full-size Orion mock-up here at the Space Vehicle Mock-up Facility in Houston. Now, of course, while they are in flight, the crew uses a potable water dispenser to rehydrate their chosen food and drink packages, and a briefcase-style food warmer for warming them up. Let's go ahead and take a closer look at how the crew eats in space.
Around the moon meal.
Around the moon meal. What would you eat? Cheese? Can you say?
Oh my gosh. That's clever. What do you think?
All right, describe. My name is Christina Koch.
And I'm Jeremy Hansen. We're crew members on the Artemis II mission flying around the moon. And when we fly around the moon, of course, we're going to be taking some food with us.
That's right. This is how to eat in space. Here we are in what we call our food lab at NASA Johnson Space Center. We come in here quite often to sample space food. The neat thing about the food selection is it is so diverse. Different entrees that you wouldn't imagine can be rehydrated and actually good in space are completely fair game. And it's pretty awesome.
We came in for Artemis to do this. We got about halfway through the first session and we're like, we're not really sure we're going to have time on board to warm this stuff up. We talked a lot about day one. It's a long day. It's hours before we even leave the launch pad on our way to space. And then when we get to space, we have a lot of important events that day. We just did a sim yesterday where lunch is scheduled. It's
midday meal.
Yeah, midday meal for all four of us. And so those would be great moments, I think, in our mission to have prep some food and sit down or float as a crew and just have a joint meal.
For sure.
I think that would be fun.
My name is Shulei Wu. I'm the food system manager for ISS and Artemis. The food lab at Johnson Space Center, that's where we make and package most of the space food, and also where we will be making all the food for the Artemis missions. Food is a big part for our crew members. They provide the nutrition, the calorie, micronutrient for crew members, but also boosting crew morale. It's very important. There is always a lot of steps, very strict steps for us to follow to making sure the food we provide are consistent and meet all the food safety, nutritional requirements, and most important, also need to taste good. The other strategy is always promote the variety because everybody's food preference can be very different. Therefore, the more variety we can have, the better to meet the needs of the astronaut group.
They bring out these little tiny samples of each food, and you're like, oh my gosh, I thought we were having lunch. And then by the end, there's so many space foods, and every time you leave, you're like, I am so full.
I'm so full, I'm in pain.
And you just rate them like, I love this, I don't want to eat it, I'd eat it if you tell me I need it. Because what the food lab does is they take all your preferences, but they're also like good parents and they're like, you need a well-balanced diet.
Exactly. They were like, no, you can't have mac and cheese every day, Christina. Sorry.
I'm Wyeth McKinley. I'm a flight controller and a crew instructor for Artemis II. We're here at the Space Vehicle Mock-Up Facility at Johnson Space Center. We're inside the Orion mock-up where we perform crew training for the Artemis II mission. On the Orion vehicle, crew is able to heat up their food using our briefcase-style food warmer. The food is held in contact with the central heater plate by these springs so that it can warm up and they can have a delicious meal. Much of the food and drink that's on Orion is rehydratable. And so crew at our potable water dispenser will fill up their food and drink, and then at that point, you go ahead and pop it into your food warmer.
I'm kind of envisioning there's maybe one person putting the stuff in and out, kind of tossing it out to everyone as it's done. Or maybe if we're not scheduled together, you're just on your own over there, popping some things in. Or maybe just in your 2 minutes of free time between things, you're kind of getting it ready so it has time to warm up. We'll see.
Eating together really resonates with me. I think it's just a human thing to break bread together and to enjoy that necessary thing you have to do, the thing you should be grateful for. And so doing that as a group, as a family, has always been meaningful for me.
Absolutely. It represents togetherness and something a little out of the ordinary. You don't necessarily get to have those meals with everybody in your life, but if you are sharing a meal, especially if you're sharing breakfast, lunch, and dinner with a group of people, that means something. It's like a camping trip.
And this is Artemis Mission Control. That was a look at how the crew eats in space. The crew is currently in their pre-sleep period, during which they have the opportunity to eat their dinner and also complete any hygiene activities in preparation for going to sleep. Once they enter that sleep period, it's about an 8.5-hour period of time, and then that will round out flight day 5. We're currently 4 days, 6 hours, and 36 minutes into the Artemis II mission, following a liftoff from NASA's Kennedy Space Center in Florida on April 1st at 5:35 p.m. Central, 6:35 p.m. Eastern. And you are currently seeing a live view of the Orion spacecraft as it makes its way to the moon. It's expected to make its lunar flyby and close approach tomorrow on flight day 6. The Orion spacecraft did recently enter the lunar sphere of influence. That milestone took place around 11:37 p.m. Central Time, 12:37 a.m. Eastern Time, and it marked the milestone of when the Orion spacecraft was being influenced by the gravitational forces of the moon versus that of Earth.
Houston for Christina.
Go ahead.
Here we have some general toilet info for you guys. We are about to terminate the wastewater dump because we have some docking camera objectives happening. We do have enough ullage for one more use. So anytime between this termination here shortly and 9:20, which is when we'll resume dumping again, one more use can happen. And then our objective is to be done with this dumping overnight, and by the time post-sleep starts, it will be ready for another use or more.
Okay, thank you so much for that insight, Mark. We've been watching the light snowstorm outside. We see the quantity coming down a little bit. And just to make sure I have the time correct, it was 09:20, and that's an MET today, correct?
Yes, that's correct.
And another question, can we use the secondary pump or the secondary waste line during these docking cam offs?
Checking. How about this? If we can avoid it before that time, that's great. If you need to use it, you need to use it.
Okay.
And you go to dump now if you need to as well.
That we're asking is, can we use the toilet if it is for fecal and not urine?
Checking. No constraints on fecal use.
Okay, I think we've got everything we need. It's amazing how many questions you can ask about using the toilet. We appreciate all of your care, and you can expect a pretty late single use of toilet near 9:20, and we'll minimize the secondary waste dumps.
Copy all. Thank you.
This is Artemis Mission Control in Houston, Texas. We are currently 4 days, 6 hours, and 50 minutes into the Artemis II mission. Currently on your screen on the left-hand side, you can see a live look of the Orion spacecraft. as it makes its approach towards the moon. This view coming to you from one of the cameras on the solar array wings. And then on the right-hand side, you can see a view of the Artemis Real-Time Orbit website, which provides updates on the real-time data and telemetry from the Orion spacecraft. And you can track this website at nasa.gov/trackartemis. Currently, the Orion spacecraft is about 233,000 miles away from Earth and about 38,000 miles away from the moon. We just heard some conversations between the crew, specifically NASA astronaut Christina Koch, currently on board the Orion spacecraft named Integrity, and the Capcom, or capsule communicator here in Mission Control, Mark Reagan. They were discussing a recent wastewater dump. These typically take place towards the end of each day. And the Universal Waste Management System on board the Orion spacecraft is basically the space toilet, and it has to empty out the urine tank each day, and it's vented overboard. The crew is currently in their pre-sleep period. They have a little more than an hour remaining in that pre-sleep period before they enter into their sleep period to round out flight day 5. Throughout the day, the crew has completed a variety of activities. They spent most of the first half of their day focused on a Orion Crew Survival System Suit developmental flight test objective. During this test objective, the crew members donned or put on their OX suits, which are those orange pressurized suits that they wear during various dynamic events, such as launch and re-entry. They then worked to get seated, and they also completed several different tasks. This developmental flight test objective did end up taking a little bit longer than expected, so they didn't complete all of the objectives. And then they moved into their midday meal, or their lunch period, and then afterwards they focused mainly on the outbound trajectory correction burn 3. This ended up being a 17.2 second burn to fine-tune the path of the Orion spacecraft as it continues to make its journey around the moon. This was the first trajectory correction burn that ended up being executed during this mission, as the first 2 outbound trajectory correction burns were canceled on flight days 3 and 4, as they were determined to not be needed due to the accuracy of the translunar injection burn, or TLI burn, which took place on flight day 2. Following that outbound trajectory correction burn, the crew then was able to do some opportunistic science imaging. So the Orion spacecraft was maneuvered into an attitude that allowed the crew to capture imagery of the moon from the windows in the Orion spacecraft cabin and provide some observations down to the science team here in Mission Control Houston. Following that opportunistic imaging, the crew just completed some final tasks for the day, and they had a private conference with the flight director here in Mission Control Houston. They typically have a private conference towards the end of every day to go over vehicle status and any other topics or questions that may be on their minds. They then entered their pre-sleep period, which is where they remain now, and during that pre-sleep period, they did officially enter the lunar sphere of influence, that milestone being passed a little under an hour ago at 11:37 p.m. Central Time, 12:37 a.m. Eastern Time.
moon directly in window 3, it just took our breath away. And for the first time this mission, the 400 mil lens, it doesn't fit completely inside the viewfinder.
That's a pretty awesome milestone. And if you feel any different in the last hour, that's because we entered the sphere of influence.
We noticed we entered the lunar sphere of influence about an hour ago, and sure enough, we are now falling to the moon rather than rising away from Earth. It is an amazing milestone. Also, earlier we had the Earth out as a crescent out the side hatch and the moon out window 3, and definitely by far the moon is bigger than the Earth.
That's such a special perspective. Thank you for sharing that.
This is Artemis Mission Control in Houston, Texas. We just heard some communication there from the crew on board the Orion spacecraft named Integrity, and you can see a live look of that spacecraft there on your screen. Those views coming to you from the solar array wing cameras. During that call down from the crew, they did acknowledge entering the lunar sphere of influence. That milestone did take place a little over an hour ago at 11:37 p.m. Central Time, 12:37 a.m. Eastern Time. By passing that milestone, it means the moon's gravity is now exerting more force on the Orion spacecraft and its crew than the Earth's gravity.
for one more photo.
Go ahead.
Hey Mark, on PCD1 and imagery for downlink, just sitting on its own, not in any folder, is 6684, which we just took with the 35 mil lens, and it's the perfect human eye perspective of the moon out the window with the interior of Orion visible. It's a pretty cool picture if you want to share that with the team or with PAO.
We'll get that down right away. Thank you.
This is Artemis Mission Control in Houston, Texas. We are currently 4 days, 7 hours, and 40 minutes into the Artemis II mission. The crew is about to enter their sleep period to close out flight day 5, and throughout the day, the crew worked on an ox suit demonstration. The Orion Crew Survival System suits are those orange suits that are worn by the crew during dynamic portions of the mission, such as launch and re-entry. And during this demonstration, they donned or put on their suits, pressurized them, and demonstrated some normal operations. During the second part of their day, they then prepared for and monitored an outbound trajectory correction burn, or OTC-3 burn. This burn took place at 10:03 p.m. Central Time, 11:03 p.m. Eastern Time, and was a 17.2-second firing of the pulse-X thrusters of the Orion spacecraft to fine-tune its trajectory. Following the completion of this burn, the Orion spacecraft was maneuvered into an attitude to allow for some opportunistic imaging and science observations of the moon. And then the crew began to wind down for the day and entered their pre-sleep period, which they are currently in and about to enter their pre-sleep period. During the beginning of their pre-sleep period, the Orion spacecraft and its crew did officially enter the lunar sphere of influence at 11:37 p.m. Central Time, 12:37 a.m. Eastern Time, which means the moon's gravity is now exerting more force on the Orion spacecraft than the Earth's gravity. There on your screen on the left-hand side, you can see a live view of the Orion spacecraft. These views coming to you from the cameras on the solar array wings. There are 4 solar array wings on the Orion spacecraft that provide power generation. And on the right-hand side, you can see a view of the Artemis Real-Time Orbit website, or ARROW, which is available at nasa.gov/trackartemis. The Orion spacecraft and its crew are now about 234,000 miles away from the Earth and about 36,000 miles away from the Moon. During the upcoming flight day 6, which will begin once the crew wakes up from their 8.5-hour sleep period, it will be an exciting day for the crew and all the teams supporting them here on the ground. This will be when the Orion spacecraft and its crew make its closest approach to the moon and surpass the Apollo 13 distance record. The Orion spacecraft is expected to make its closest approach around 6:02 p.m. Central Time, 7:02 p.m. Eastern Time on April 6th. During the closest approach, they are expected to be at a distance of 4,070 miles from the surface of the moon. And then a few minutes after that milestone, the Orion spacecraft will reach its farthest distance from the Earth at a distance of 252,760 miles, which is 4,105 miles farther than Apollo 13 went. In addition to these milestones, there will be an approximately 6-hour period of time allotted to allow the crew to make observations about the moon. This is the lunar flyby observation period. And the crew's observations, handheld photography, and images from the Orion spacecraft will form the basis for scientific investigations into the moon's geological history, the lunar environment, and current processes such as new impacts. Again, all of this coming up on flight day 6, just around the corner.
Houston Integrity on 1 for email.
With you, Reid.
Hey, Mark, as we have passed into the lunar sphere of gravitational influence, I think that fixed it. Huge thanks to the team down there as we head around the moon tomorrow. It is really great to be reunited with some family, and I appreciate all the effort that you all have put into it. And email is working great. Thank you so much.
Glad to hear the confirmation of that. You're welcome, sir. Have a great evening.
We will, and we are assuming that we can start doing secondary dumps at 9:30 MET. If that changes, please let us know, because we do plan to use that capability.
(9:30) is a good time. No changes to that.
Okay, in that case, we're all studying our lunar targeting packages here. You can see the glow in everybody's eyes from the PCDs, and we're going to head off to slumber here soon. Thanks.
Awesome. Sleep well.
This is Artemis Mission Control. We just heard some communication there between the crew on board the Orion spacecraft, specifically NASA astronaut Reid Wiseman and the Capcom or capsule communicator here in Mission Control Houston. They were talking about a couple of different topics, including some email access. That access was being worked by the CDH position here in Mission Control. That stands for the Command and Data Handling console, which monitors various computers and aviotic subsystems on board the spacecraft and ensures the health and functionality of the spacecraft's electronic equipment. The crew also mentioned that they were reviewing their lunar targeting package prior to heading into their sleep period. That lunar targeting package is the primary tool that guides crew observations during the lunar flyby, which is planned for Flight Day 6, which will begin upon crew wake. And it consists of two key components: the Lunar Geography Review, which helps astronauts study major lunar features and also how to orient themselves during the flyby, as well as the Lunar Targeting Plan, which provides a detailed timeline of observation targets, along with some background science context and specific instructions for imaging and verbal descriptions. The Artemis II crew also trained with a Lunar Science Passport, which is a reference guide used on Earth to reinforce the recognition of key lunar features. And while it didn't fly with them, it did support the crew readiness in advance of the mission and the upcoming lunar flyby. The apparent size of the moon will change throughout the flyby. It will appear roughly like a basketball held at arm's length at closest approach. Again, we are expecting that lunar close approach to take place around 6:02 p.m. Central Time, 7:02 p.m. Eastern Time on April 6th. The closest approach will be at a distance of about 4,070 miles from the surface of the moon. This is Artemis Mission Control. The view that you were previously seeing was coming from the docking camera on the Orion spacecraft. And now the view you are seeing here is coming from the solar array wings on the exterior of the Orion spacecraft. That view pointing down towards the service module. Specifically, you can see the thrusters at the base of the service module, those auxiliary thrusters along with the main engine there in the center. This is Artemis Mission Control in Houston, Texas. We are currently 4 days, 8 hours, and 22 minutes into the Artemis II mission, following a launch on Wednesday, April 1st at 5:35 p.m. Central, 6:35 p.m. Eastern Time. The crew on board the Orion spacecraft recently entered their sleep period about 40 minutes ago. This will be an 8.5-hour period of time. Following the conclusion of that sleep period, they will begin Flight Day 6. Flight Day 6 will be an exciting day for both the crew as well as all the teams here on the ground. This is when the Orion spacecraft and its crew will have their lunar flyby. During this period of time, they will also make the closest approach to the moon. That is expected around 6:02 p.m. Central Time, 7:02 p.m. Eastern Time on April 6th. This approach will be at a distance of 4,070 miles from the surface of the moon. And then following that milestone, the Orion spacecraft will reach its farthest distance from the Earth at a distance of 252,760 miles, which will surpass the Apollo 13 distance records by 4,105 miles. During the approximately 6-hour lunar flyby period, the crew will be making observations about the moon, and the crew's observations combined with handheld photography and images from the Orion spacecraft will form the basis for scientific investigations into the moon's geological history, the lunar environment, and current processes such as new impacts. Artemis II lunar science deputy lead Marie Henderson was one of the trainers who helped prepare the astronauts on board the Orion spacecraft to capture and document their views of the lunar surface for all of us back here home on Earth. So let's go ahead and learn a little bit more about how the Artemis II crew will capture the moon for all of us here at home.
I cannot wait to hear their voices when they get to the far side of the moon and I can hear them talk about seeing the moon out their window. I try to imagine it now and just I tear up thinking about it. Ooh, now I gotta hold on a second. We have human eyeballs connected to wonderfully smart brains our astronaut friends have. They are going to be able to observe the moon in multiple different ways. They can use their eyes, they'll look through their camera and snap pictures, and just looking out the window getting that human experience. But during Apollo, the astronauts were so much closer to the lunar surface. Our astronauts are going to be doing a flyby at a higher altitude, so they're going to be able to see the whole moon as a lunar disk on the lunar far side. That's a brand new, unique perspective that humans haven't been able to look at before. We are doing a lot of lunar geography training with them. They have study sessions and quizzes they can do that are assigned to them. You know, even if you're an astronaut, you still get homework. We actually get in the mock-up. In that enclosed physical space, we have to think through the hardware that they have, the cameras, the computers, their microphones to make these observations. There's 4 windows up front. Through one of those windows, one of our astronauts will be using a Nikon D5 camera with an 80 to 400 millimeter lens. So something that allows them to zoom in really far and actually take more detailed observations of the surface. It's almost like looking through a pair of binoculars as well. It's just like being a geologist out in the field. They're telling us what they're seeing, looking for colors, textures, different morphologies, and comparing the region that we're having them look at to the regions that are around them. We have a science team that is planning the targets that are going to be observed, putting them all on the timeline of how they're going to be observed, and then taking the first look at the data when it comes down. The Apollo astronauts were only on the moon for 300 hours total, and they only went to the equator. That's like going to places that were safer landing sites, and they only saw so little, 300 hours total. And so we have so much more to explore and so much more to learn. And we are the beginning of the next generation that gets to start being a part of these discoveries.
This is Artemis Mission Control. You're now seeing a view of the Artemis real-time orbit website as the Artemis spacecraft continues to make its way towards the moon. It entered the lunar sphere of influence a couple of hours ago at 11:37 p.m. Central Time, 12:37 a.m. Eastern Time.
This milestone marked the moment when the moon's gravity started exerting more force on the Orion spacecraft and its crew than the Earth's gravity. The Orion spacecraft and its crew will remain in the lunar sphere of influence for the next couple of days, and it'll officially exit the lunar sphere of influence on flight day 7. That view on your screen there, the left-hand side, is a view coming from the docking camera on the Orion spacecraft looking at the moon. And then on the right-hand side, again, is that visualization, which provides the data and telemetry coming down from the Orion spacecraft itself.